We're on the precipice of Starship Flight 6, and there's huge news to talk about, so let's just get right into it. Roll the intro.
And here we go. We have liftoff. Propulsion continues to be normal.
R68 chamber pressure looks good.
Following up. Climbing downside FD off. Bring in FD off. It's orange! Orange 45! Oh my god! Oh my god! Decollage! Oh, look at this! Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This is definitely going to be an igniting flare, correct?
We don't need any more of these.
All right, well, let's just jump right into the big news of the day. Dee, tell us what the heck is going on.
Absolutely. So I believe yesterday evening it was announced that ABL Space Systems is moving away from their space industry and moving into missile defense. So, I mean, there's a lot to talk about here.
It's quite a pivot. I can't even. No, seriously, best of luck to them with their pivot. But no, we're here to talk about Starship, so let's talk about Starship. You might have noticed, we're all in the same room. We built a little set in a little studio, and yeah, we're hanging out. So I'm Jack Beyer for NSF, if you didn't know. That's Max and Dee. Max and Dee, say hey.
Hello. Hey.
So yeah, welcome to the NSF Bunkhouse. It should be a good one today. We've got a lot to talk about, and I see some support coming in already, so thank you for that. Also, Kevin in the background operating today's stream. And so thank you to Kevin, and thank you to Dee for getting this whole rig set up, because holy cow. We spent the better part of the morning getting all of this nice and ready to go, and should work out. But yeah, let's just jump right into it and talk about where we're at with Flight 6. We will be talking with Adam a little bit later, Adam Suker, our resident weather guru. So we'll have a little bit of a weather update. We also have some special guests. I don't know, am I supposed to tease the special guests?
Yes.
Yes, we have some special guests to talk about the sonic booms. And that should be really cool, because we hosted some folks for Flight 5 to get some special, scientific data about what those sonic booms exactly are like in terms of volume, intensity, distance from the launch site, etc. So that'll be a really interesting discussion. We're going to have Das and some folks on for that as well. So let's jump right into it. But Max, you went out there today to shoot a little bit, and Full Stack was standing pretty. How was that, buddy?
Full stack was standing pretty. They stacked yesterday, which actually surprised a bunch of us. We thought it might happen at some point today, or if not this morning, but they wanted to surprise all of us and stack last night. So Stack was out there sitting pretty. We saw them do a bit of grid fin testing, and yep. I don't know if we've seen them do any flap testing yet. We thought that might happen, but so far I don't know. I haven't checked footage.
Right. There was the DSS test and a possible igniter test too. Did you get to hear any of those or see any of those?
I heard a lot of stuff out there. It's hard to tell because obviously you can't look right into the bottom of a Raptor, so you can't see if that's actually what that was. But there's always a lot of noise coming from a full stack usually.
Good deal. Also new today. There is, well, I guess not new today, but something of note in terms of updating everybody where we're at ahead of Flight 6 is there is still that road closure for Sunday, which we expect would be used for some sort of full stack, maybe like wet dress rehearsal or proof testing. Dee, any idea like what is going on with that? Like, can they do that and then still launch Monday? I mean, have we heard anything in the way of how things are going?
I mean, if they do like a full wet dress rehearsal, I believe a launch Monday would be off the table. So when that road closure came out, it's definitely been a little bit confusing as far as like what are they actually going for? Are they planning to launch Monday still? Are they maybe going to move for weather reasons? Because weather has been a little bit of thing that everyone's been looking at. I know that we'll go into the weather later, but I mean, if they do shift a bit, then they would have time for a full wet dress rehearsal. And it's also interesting just to see like how fast these things are coming up. There was even a moment of speculation where I was saying like, are they trying to shift left because of the weather? Like
I remember that. Yep.
That didn't seem like it would be the case, but you never know. But I definitely don't think that would be what's happening here. I would think probably a potential wet dress Sunday and then launch maybe Monday, maybe Tuesday, Wednesday.
So we'll probably talk about this a little bit more once we get into the weather with Adam. But there have been some reports floating around that, don't call me right now, people, you know I'm live. There have been some reports floating around that flight could potentially move to Tuesday based on weather considerations. So my thinking is, if they do test on Sunday, it's not really thinking, my question is, if they do test on Sunday, do they still have enough commodities to actually fly on Monday if the weather is good? Like, is it an if or situation?
I think it's an like a one or the other. Like I feel like probably by tomorrow they'll have, because weather changes so much. Even the day of, you don't know for sure. But I assume tomorrow they'll have a better idea if they're gonna prep for the road closure, prep for fueling tests and that sort of stuff. Because I mean, as media, we also have our preparations to do, and we have our sites with SpaceX that we go to, and so all that stuff needs to be figured out a little bit in advance. So like we can't set cameras if there's a road closure all day.
Presumably.
Yeah, who knows?
But yeah, so that's something to look out for. You know, it'll be kind of a tell, potentially, if they do end up doing that testing on Sunday, you know, or if that road closure doesn't go away tomorrow, maybe Tuesday. But again, we'll talk about the weather more in a little bit. Let's see, what else is new today? We talked about the Sunday closure. We talked about the booster on the pad. We talked about the full stack. Max got to see it. I'm jealous.
As if you haven't seen so many already.
Yeah, but still, you know, you only get so many days with a full stack. Like, you kind of got to take advantage of it when you have it at the pad.
I've seen this full stack too, so you're the only one here who hasn't seen this exact full stack, right?
No,
Oh my gosh, yeah, you're right.
I have. No, okay, story time with Membies.
Oh, yes, I forgot.
Story time with viewers. No, for real. We were all out there yesterday to film the full stack. I came back here to be on stream for the full stack, and I asked Max to please grab my time-lapse camera before he left. Did you do that, Max?
So anyway, the weather.
Yeah, right. So yes, I have seen the full stack because I did go and grab my camera in your face.
I was trying to help you out, you know.
Yeah, no, you did good. Thank you.
But
y'all,
you
don't
didn't
forget,
help
if you
out
have any questions, feel free to ask them. Type at NASASpaceflight in chat, and we'll see them pop up in some software we have running in the background. Here's one from Phil asking, could they have preloaded the flight termination system? So, this is obviously a hot topic, because one, it's explosives. Explosives are hot. It's funny. It's a funny joke. But also, we typically look for FTS install because then that's how we know this is going to be the final stack, right? So I don't know. Let's just go around. Do we think that they could have preloaded the FTSD? I'll throw it to you first.
Oh, now I'm the first one.
You're the first one. I'm looking right at you, buddy.
I'm not. I don't think so, but I also saw people saying that they did, and honestly, I don't know. I can't give a solid answer. Like if they're going for a wet dress rehearsal, like their timeline's going to be short. They are clearly very quick at being able to stack. We saw they rolled out the booster yesterday, early yesterday morning, and then they stacked yesterday evening. They don't have to do a rollout here, so like if they do just lower the ship, I don't know. Yes, so there's your non-answer answer.
That's an answer. Max, what do you think?
Well, I think you can't just keep having to destack the whole rocket to install FTS at some point. At some point, the FTS is going to have to be installed well beforehand in order to save time to launch quickly and effectively, like they want to.
Right.
I mean, you don't see SpaceX rolling out like T minus, who knows, like a day before launch of Falcon 9 installing FTS. It's already integrated. It's already integrated, exactly. And at some point, they have to be able to do that with Starship, especially if they want to fly as often as they do. So, especially with this being the last V1 Starship, maybe they tried to work that in somewhat to, I guess, practice and put effort into, integrating that into V2 Starship when that flies for Flight 7. But they very well could have. And also, I would not rule it out if they were to do, say, a mini wet dress even with the FTS installed.
Yeah, I mean, my gut, right, just based on everything we've seen so far, is no way, Jose, would they preload the FTS. But you make a really good point, Max, that at some point, logically, just to reach the cadences that they're talking about, airliner-like operations, right, they're going to have to do that. You don't see a plane at the gate being pushed back by a tug, and they're like, hang on, we got to install the APU. Like, that's just it's just not how that works. So I understand where you're coming from, and I don't disagree. I don't know if it'll happen on V2 or later or what. Or maybe it's already happened with this stack. I guess we'll see if they do end up destacking it and putting FTS on it. At this point, that's really the only way that we're going to know.
Yeah.
It's a really good question, though, Phil. Thank you for that one. And again, y'all, if you have any questions, keep them coming. We're keeping our eyes on chat, and we will be answering every single one that we can. Here's one from Adamo asking, whenever Raptor 3 comes online, do you think it would be necessary to prove relight capability Do you think it would be necessary to prove relight capabilities in orbit again because Raptor 3 is so much different than Raptor 2?
I think at least once. At least once, just to verify that yes, the whole system works again in orbit. It works as it's supposed to. And obviously, Raptor 2 and Raptor 3 are hardly even comparable, just in terms of how they look, let alone how they perform with their differentials in performance. But I would say at least once. Also, NASA might want to see that more often just to demonstrate that, yes, Raptor 3 is reliable in orbit and also in a vacuum as well.
Right.
So,
zero-G vacuum.
Yeah.
Do you think it would be a suborbital flight? Like, do you think we'll still have that be a suborbital flight?
That's sort of what I was...
if they're actively trying to test relight, how much of a relight test is it if it's critical to deorbit?
Right.
Like, that's not really a test at that point. That's just being reliant on the system and seeing if it works. So the question would be, like, if their ship goes orbital with Raptor 2, and then they go to Raptor 3, do they go suborbital again, or? That
would be curious, right? To be launching, presumably to be launching Starlinks on version 2 of the ship, and then to go back and revert to, you know what, maybe what they might do is, this is complete speculation mode, so sound the alarm. But what they potentially could do is have a mix of Raptor 3s and Raptor 2s on the ship. That way,
that seems cursed.
That does seem cursed.
No, hear me out. Center engines Raptor 3s, Raptor Vacs, Raptor 2s. So if your in-space burn of a center engine goes kaflooey, to use a technical term, then just fire up one of the RVACs that's a Raptor 2 and you're good to go.
So part of the testing of the relight isn't just the engines, though. That's like all the fluid control in space. It's all the other systems. And so some of that testing will still somewhat carry over because it's like the tank design and all that sort of stuff, right? So even if they don't do I could see them, if they have gone orbital, like fully orbital, when they do the switch to Raptor 3 flying, I could see them just continuing to stay orbital because they're going to have so much Raptor testing.
As if they haven't already.
They're going to have. They do so much Raptor testing. What was it that got hit at one point? It was 35 by one engine in one day?
Yeah.
I think it was 35 back-to-back, but in a single day it was like 54 or something.
Oh, my gosh.
Like
it was also, I think it was also like 35 or whatever in an afternoon. Like, it wasn't even like a whole day. It was an afternoon.
Right. It was like literally back-to-back to back-to-back.
I was telling someone about how they did this rapid test, back-to-back testing, and then I pulled it up again, and it was 12 tests in a row of the same engine. And I was like, well, that was convenient timing.
Yeah, and at the time we were all like, why are they doing all these rapid-fire tests? Well, I'm going to find out. Tripod's decommissioned. So one heck of a way to send off the tripod.
They're just putting it out in a blaze of glory.
Yeah,
or at least they tried.
They tried.
They tried.
Of all blazes of glories, I think that is one of all time.
I mean,
would you agree?
The tripod as a whole has seen its fair share of Raptor failures to this point, over both Raptor 1 and Raptor 2. But the fact that they weren't able to blow up a Raptor 2 by igniting it 30-something times in an afternoon,
right.
like that speaks volumes of just how far Raptor 2 by itself has come in its 2+ years of development, and where Raptor 3 might be going in the next 12 months.
Well, and that ties back in what we were just talking about with the in-space relight. If they're able to gather enough heritage data for Raptor 3 just on the test stand, and it's, functionally performing the exact same way that they would expect a Raptor 2 to, I'm so not an engineer, can you tell? But if they get enough data on the stand, maybe Raptor 3 doesn't need to, necessitate an additional in-space relight. That's my non-engineer take. Let's see, a bunch of questions about FTS, but you know what? I'm going to go with this one from Supersonic Retro Propulsion, because that is like the coolest term ever. They're asking, what % chance do you give the ship making it all the way to a soft splashdown? Now, some of you out there might be thinking, oh, they have already done it twice. It's totally fine. It's chill. It's going to make it. 100% chance. But.
It's a big but. There's a big but here.
There's a big if here, and the if is, will the heat shield work? Because this is not the same heat shield design that has flown on all previous flights. Significant amount of tiles have been removed from the sides of the tankage, something like 8 rows, which is quite a lot. And if you look at a side-by-side of Ship 31 versus all previous ships, it's dramatic. I mean, you've both seen previous versions and this new heat shield. I like it. I think it's gorgeous. What do you think?
I think it's awesome, but there is a whole lot more exposed stainless steel on the side of the ship. And on top of that, I believe they're testing entering at a higher angle of attack this time. So those are a number of things that are changing this time around. So I think they'll make it to a soft splashdown. I would give it 7. I mean, these are invented numbers. I'd give it a 70% chance. Like, I think they're going to do it, but they are testing some new things, so there is that chance. Right. Maybe I'd go 75% chance.
I would say 80, but maybe I'm just overconfident from seeing a bunch of soft splashdowns already. I say a bunch, but it's been like, what, 2?
2. But all that being said, so they've taken off a bunch of the TPS from the sides, but they've also taken off 4 from the nose cone, and also 2 more from down by the skirt.
That's correct.
So, and the goal eventually is to minimize the amount of TPS on ship, if any TPS at all, beyond the actual stainless steel tank structure. So I think this isn't quite like shuttle, where these tiles were covering up an aluminum surface, which is much more vulnerable to higher reentry temperatures. But at some point, they're also going to have to demonstrate the fact that if they don't want to have TPS, that their current tank structure or their current stainless steel alloy can withstand the current temperatures or higher temperatures from reentry.
Well, and it's necessary, right? Because the reason that they've removed these tiles is not only to just test the heat shield itself, but also be able to, in the future down the line, install the hardware on the ship that's necessary to catch it. Because right now, no ship we've seen so far, I think that includes 34 and 33, which are the first Block 2 ships, have catch hardware. Nothing we've seen so far on a ship has catch hardware, to my knowledge. I could be wrong. So, in order to enable that, they need to start doing tests like this. And it goes back, takes me back a little bit to before Flight 5, when we were in the brawl of the FAA misery, to put it lightly. And, everyone was saying, oh, why would they refly the same profile as 4? Or why would they not want to go for a catch? What could they even possibly test? Well, now we know. In-space Raptor relight, crazy heat shield modifications, higher angle of attack on reentry with the ship, probably some other stuff I'm forgetting, but yeah, a lot going on differently with this flight than even just Flight 5. So there will be no shortage of excitement on this one, and I don't know, what else can I say? I'm excited. Are you guys excited?
Very much so.
Oh yeah, this is going to be a really, really cool launch. Now, if we bounce off of that question, What do you think the odds are they catch the booster again?
Oh, I would say 80%.
I'd go between probably like 75 and 80 as well.
Okay. So the basis for this question, am I correct in assuming that the basis for this question is how lucky did they get on the first catch?
They got pretty lucky. Like they
were within 1 second of an abort.
Yeah. So, everything had to be right. And it was right. And then there was, I think it was referred to as 1,000 control cycles.
Something like that.
Which was like 1 second of time where they would not have caught it. And so like everything got worked out, and I'm sure they won't have that issue again. However, I gave a very low chance last time that they would catch the booster. I don't think we're at 90 or 95% chance. I think we still might be at a 70, 75% chance for that.
I don't know. Ozzy in the chat says 99% chance of success.
All right. Now, do we break it down? What do we think the odds are that they go for a booster catch?
Oh, that's also a very good question. I'm going to say highly likely. I feel like at this point, Ascent is kind of nailed down. And it's hilarious for me to even say that, given the fact that we're only on Flight 6.
Yeah.
There's probably engineers in Starbase right now who are like, it's not nailed down. What? But yeah, I feel like they'll go for a catch again. Although the confounding variable there, to me anyways, is weather. What if the booster before or during the boost back burn gets hit by some shear or what have you, something causes an issue in that regard, and they decide to not go for it.
Or sorry, go ahead.
It's okay. I wonder if there's also any visual constraints involved, or if the cloud coverage is too thick and they can't really see it. Because remember, with SN11 and SN15, visibility was awful.
Awful.
But they still opted to fly and try to try to land a ship. So
my visual for SN15 was, hang on, perfect opportunity. I'm EJ. My visual for SN15, here we go. This is the cloud layer right here. And then 8 minutes later, that was it. I was like, okay, well, I saw it.
I hope that's not what happens for Flight 6.
Oh, don't jinx it.
No, we're talking about something else.
Moving
right along here. Matt Scholasar, thank you so much for gifting 50 Red Team memberships.
Wow.
Don't you jinx the weather, Max. 50 Red Team memberships is insane. Thank you, Matt. And we always see your name pop up with huge amounts of support, so thank you for that.
Now, the other consideration for going for booster catch is chopsticks. And I will say we were both out there during the lift, and the chopsticks are really loud. They have the wear of a couple flights.
They scream.
They've had
they scream in pain as they lift or lower a shower booster.
And now they've had 1 month, between 1 month and 2 days, I guess, since the last launch and catch that they did. They haven't done a ton of refurbishment, so who knows if after they endure another launch, something doesn't look good. There are so many considerations. We take recovery with Falcon 9s for granted for a lot of things.
I think we're rapidly approaching the point where we take Starship recovery for granted, even though there's only
I think we are too. I would absolutely agree with that. We've seen one recovery of booster.
Yep.
Right.
Not even a reflight.
Right.
And
Yes.
Now, we're. When do we think we're going to see?
2025. I think we see reflight of a booster in 2025. Not ship 26.
I'm in favor of this. 100% in favor of this.
I've said it from the very beginning. Booster 12 and Ship 26 would be the best candidates for a reflight. I'm just saying it is, because think about it. Booster 12 obviously has no future beyond a reflight, probably with how beat up it is. And also with the Block 1 version of boosters going out of style probably in the next 12 months. And with Ship 26 also probably having little future, it'd be a very expensive scrap.
It has a long future in our hearts.
But imagine Ship, I've said it to you before, imagine Ship 26 going out in a blaze of glory.
I'd be
so that way, Ship 26 is gone, but Ship 26 flew.
This is the most hyped up I've seen Max since you got here.
Honestly, yeah. I want to see
Ship 26. We all love Ship 26.
We want Ship 26 to fly.
Yes, we do.
Cut it.
If we have to get rid of Ship 26,
I will only accept it in a flight.
All right.
Whether that is
Death by flight.
hey, it can be. They can mod it out and make it a cash test. Yep.
Sure. I'm fine. It doesn't even have flaps. What do you think?
It needs heavy modification, mind you.
No, fly without flaps, just to see how stable it might be.
Let me go through some support here. We are coming up on our spot with Adam with the weather, so we can talk about more of those considerations that might be pushing launch toward Tuesday. We don't know. There's been some reports floating around, nothing concrete. But so plan for Monday right now. But again, coming up with Adam here in just a moment. But I'm going to thank some people for their support because you know what? We can't do crazy stuff like this or stream rocket launches from the Cape, from Kennedy, from Vandy, sometimes when I'm in LA, and from Starbase without you guys' support. So thank you. Anonymous, grabbing the Flight 6 patch, which is out, by the way. We revealed it. They say, Dougal will be getting some demerit points. Will we be getting some demerit points on this stream? I don't know. You're gonna. I think you do deserve some merit points for this setup. Like we don't have a reverse camera where we can show all of this, but maybe we should post a photo in. Yeah,
All right, just walk into the shot. Get it from back there.
Yeah, just walk
get it
into
from
the-
behind us.
just
Yeah.
Come over.
Walk into this show.
Like right here is perfect.
We're all very professional here. Hey, it's Das, and chat goes wild. And the crowd softly chants,
All right,
Das, Das, Das. Okay, all right. That's enough.
I'll put it to the members.
Yeah. Das is going to upload that photos in the member Discord. But yeah, I keep putting my stupid screen to sleep. I really should not use hot corners on a stream. Thank you, Steve Jobs. Jerker, thank you for the support. Meaningless, thank you for the support. The $20 super chat, holy cow. They say, is it possible to see the rocket after launch from Corpus? My parents are currently on the south side of Baffin Bay, south of Corpus Christi.
Now, this is shooting the gap south of Florida.
Yeah.
Right?
Corpus is north of Boca, though.
Yes.
But yeah, how far north is that? That's a couple
Like 2
hours.
hours?
So I want to say it's roughly the same distance as. So Corpus Christi from Boca is about from Jacksonville to Cape.
Oh, that's exactly what I was thinking.
And people from Jacksonville can see launches, although Falcon 9's exhaust burns a lot brighter,
Right.
and it's most visible obviously during night,
Right.
during night launches when there is that contrast between a bright exhaust and dark sky. Whereas we've seen now many times from ship flights and now full stack flights, the Raptors don't burn that bright.
Right.
So I'm really curious to see how the whole exhaust plume by itself will look against a different colored and lit sky compared to flights 1 through 5.
Yeah.
So
Yeah,
to answer your question, I genuinely have no idea. Maybe the stainless steel structure will have enough light to reflect off of it to make it visible, but I don't know. I hope so. I hope so.
Yeah. So meaningless. My advice would be go outside. You know what I mean?
There's one way to find out.
If you want to be watching the stream, you can take it on your phone, go outside, look up in the air, see if you can see it. And if you can, please post that somewhere and tag us because we love seeing the stuff that everybody gets to see from all the different angles. Like whenever there's a jellyfish or what have you, and people all up and down the East Coast are posting jellyfish photos. So hopefully your parents are able to see it. Sorry, we don't have a more concrete answer for you, but fair chance. Musical Wolves. Thank you for the support. They say, will holographic stickers be a permanent option? Das? That's a thumbs up. That's a thumbs up from Das. You don't have to worry about the stickers selling out. Thomas Benedict got the Flight 6 patch. Thank you so much. They say, if SLS is canceled, do you think Starship would be able to quickly be used during the entire mission, launch to landing and back? Or would Dragon have to be used to dock to it? How about other commercial options for future Artemis missions?
Either way, I think it's probably safe to say that option, the latter option, will be cheaper.
To me, and I am so not an
Or
engineer.
less expensive, I should say. Less expensive.
I'm so not an engineer. I think that's clear. If you launch an HLS ship, dock it to a tanker, load it full of propellant, depot, not a tanker. Load it full of propellant. Sorry, former Senator Shelby. Depot. Fill it full of propellant, then launch a Dragon on a Falcon 9, dock to the HLS guy, go to the moon. Go to the moon, do moon stuff, come back to Earth, maybe dock with the Dragon again, have the crew come back down. That seems like super straightforward to me, minus the 16, 18, 20-something tanker flights. But, Who knows what's going to happen with SLS?
That question as a whole could open up an entire.
We could talk for days
Yeah.
about this.
Rest assured that over the next period of time, shall we say, we will be talking about this a lot, especially as more news comes out and more sort of rumors hit the rumor mill and all of that. But
yeah,
let's stick to Starship today.
Go
ahead. It's a flame trench. It's a flame trench.
I really want to see SLS fly more. We got a flight already. I want to see it continue to fly, and I want to see Orion get its proper use. Like, there are potentially alternatives that could be developed, but purely from a visual standpoint, like, I want SLS during the day.
Yes.
I want to have more opportunities to shoot it.
Yeah.
The combination of liquids and solids is always great.
If I never get to photograph a nice shot of RS-25 mock diamonds, I'm going to be a sad boy.
So, tough question for both of you now.
Yep.
How many times will SLS fly?
3.
3.
Oh gosh.
That's honestly probably being generous. If I'm really looking into my heart of hearts, but who knows how things are going to pan out.
I see 3 or 4. Unfortunately,
Unfortunately.
I mean,
unfortunately,
only 3 or 4. Unfortunately, is my take there. I want to see more. I want more SLSs to fly. I want more of every rocket to fly. I want ABL to fly RS-1 more.
Yeah, that's true. That's true. I mean, I hear you, and I'm a fan of shuttle-derived hardware. So it would be nice to get a daylight SLS launch.
Yeah. We were really trying for it hard for Artemis 1. We almost got it a couple times.
There was 4 scrubs, right? And there was a couple of those where it would have been like daybreak or something like that.
I think there were 3 complete into the count scrubs before because there were numerous delays. But once they actually got into the count in probable, I think it was either 2 or 3 actual scrubs. But I think on 2 of those occasions, yes, we were trending into daylight hours, if not late morning into afternoon. When for us at the price site, the sun would have been at our back.
All right.
So,
well, we'll see what happens with SLS, but what we will also see what happens with is the weather on Monday. So let's hear from Adam. Oh, actually, Adam needs a minute, so I'm going to thank a couple more people, and we will then go to Adam really quickly here. I do want to thank Snot Garden, even though they have the literal worst name, for gifting 5 Red Team memberships. We love you, buddy. Thank you for always popping in with the support. I still don't understand your name. Anonymous with a store purchase. They grabbed the patch and a sticker sheet. They say, great content. I like the bunker. Ooh, should we call this the bunker? We've been calling it the bunkhouse. I mean, I
like the bunker.
Bunker sounds good.
I like bunkhouse. It has rocket heritage. Like blockhouse.
Okay,
yeah.
Then just call it the blockhouse.
But it's not a blockhouse. It's a bunkhouse.
Isn't?
If it was near the launch pad. Okay, moving on. Adam, do we have you in comms, good buddy?
I'm here, Jack. How are you?
Doing good. Max and Dee are here with me, and we are all, as photographers, cinematographers, etc., dying to hear what's going on with the weather. So please, if you would, let us know what the heck is going on, because you have this stuff on a lock.
Oh, absolutely. The hardest thing with this is, obviously we've only had 5 flights. So since SpaceX doesn't really give us a chart saying, hey, these are what we have to go by, if we have, certain wind profiles here, we don't know all that information. So what I've been doing is gathering information, just like we've watched over Starship flights and everything, is gathering as much data as I can and then going based upon what I can see. So I have basically 5 data points from the last 5 launches. But here's the catch. Exactly what I just said, the catch. So I only have 1 data point for that. So, I don't even think I meant to do that. So I only have 1 data point from that to go by. And that data point was a beautiful day. And there was barely any wind shear. There was nothing really to go by. So I don't have a lot of great data points. So I have a little bit though to work with. And weather is one of those that we do know certain points that are good and not good for obviously rocket flight. So we'll go based upon those data points to see what day, because we have Monday, Tuesday, Wednesday. We have 3 potential days. You got your primary on Monday and Tuesday and Wednesday the backup. So let's look at those 3 days in general to see which day looks the most favorable. He's got the basically what the public sees if you go out and look at, your weather forecast. This is actually from the National Weather Service in the local area of Brownsville. And they put out for Monday a 30% chance of showers, mostly sunny, high near 86, breezy. Keyword breezy, south to southeast wind 11 to 21, gust to 30. So from yesterday, gusts were still going to be up there. They're going to be up there in the upper 20s. And some of the latest data, right before I came online here with y'all, I was looking at a new model run just came out, and I'm looking, and it's pushed that wind threshold a little bit higher in these last few runs at the surface.
Yikes.
Well, obviously, if you want to catch, there's got to be a threshold somewhere where the wind at the surface is starting to blow too strong to come in, because obviously when the rocket's coming out at a slower momentum, that wind's going to push it around a little bit more. So to me, looking at some of the latest weather guidance, the wind, it already looked like it was getting up there close to threshold criteria for Monday. And another thing on Monday is, if y'all go to the next slide, Monday is a day too that we have this Pacific cold front that is moving in with a storm system. There's actually so for instance, McGregor up the road, 6 hours where they do the rocket testing, there's actually potential for severe weather there. Well, down to the south, we're going to be right on the edge of that. So where the little red X is that I drew, that is, basically Starbase. And that is the front at 3 p.m. So an hour until the potential launch window. That front's moving in close. Now, the blue is indication of clouds. Those clouds are basically cumulus clouds that are bubbling up along the front and ahead of the front. Okay, well, if we've known anything with Florida, cumulus clouds obviously can be energized with static charge, discharges, lightning. So, with that said, the front is literally 2.5 counties out to the west by 3 o'clock. And out ahead of that, yes, it shows it's clear directly over Starbase like we want. We'll take it with a grain of salt. This is just one computer model run. But seeing that means there's going to be broke up clouds. So it won't be full sun. There will be sun. There's going to be some broke up clouds. I'm expecting some of those cumulus clouds. But we have to worry about cumulus clouds equal lightning discharge too. They could be far enough away. It could be very close to where they're getting, potentially nervous, because in those afternoon hours, we have to be careful with as this front approaches. So do you want to make the risk? Now, with that being said, with this front, the cumulus clouds and the strong wind shear, I feel like personally, I heard Jack, you kind of spoke earlier on it about some of the speculation. I can actually see why Monday is a very close to marginal day of where they could be getting close to that threshold where they're going to be a little bit nervous about Monday, about potential flight because of weather. I looked in the Indian Ocean and I don't really see any much issues there for splashdown for Starship, but looking here close to the launch site, that's where we have to kind of watch. But now, if we move on to the next slide, and I wish I always had good news. The last launch was so easy to do.
Why can't we have that every launch?
Anything to worry about. So this is what we call a profile. So this is basically a sounding, and this is as the rocket goes up in the air. And so from the little blue circle line that I drew, if you can go down a little bit, it's from the surface and goes up.
Is that shear?
That is wind shear, exactly. So those wind barbs are pointing in the direction the wind's coming from. So at the very bottom, you see the first one. That's 20 knots from the south-southeast. Okay, the last launch we had, Flight 5, it was only 10 knots, half that value just even at the surface. So it's double. So we've gone from 10 knots to 20 knots. And miles per hour, it's relatively close. It's basically close to 10 and 20 miles an hour. But that's just steady wind. And then you got to factor in wind gusts. We can have wind gusts up to 30 miles an hour. And I know for even the Falcon vehicle, that's most likely close to threshold, if not exceeding thresholds. Now you have a larger vehicle, that's going to have more wind mass moving that vehicle. So this makes me nervous. And the one thing I noticed is the directional shear, the values have come up. So that last 3 kilometers, which is probably really crucial too for them as that rocket's coming down for the landing, the wind's changing directions and pushing the ship all the way around if it was to come through that. You don't really want strong directional wind shear. So to me, this is like right on borderline. Like they're probably watching this real close. But here's the thing: in meteorologists and computer model worlds, we're right now like 74 hours out in computer model land. So like there's still more models that come out. The forecast still is going to get defined. They launched weather balloons literally down to the last hour over at Starbase just to verify that the computer models aren't wrong and that exactly what is their threshold. So like they sometimes will get down to that, but if they see a lot of these values, they're like, if you can go on the next slide. But let's talk about more about what about another day, like Tuesday, for instance.
Like
So,
Tuesday. Tell me Tuesday's better, please.
So Tuesday is better. And this is where Tuesday, if you notice, we actually have the wind barbs are actually pointed out of the north. We actually have a Pacific cold front that's going to push through Monday night to Tuesday morning, but it's only at 10 knots from the north, back to normal levels of what IFT5 was. Because of that, I believe that, and yes, there is some directional shear, but the wind bobs are showing 5 knots, barely anything. It's not a lot of change of wind. So the 0 to 3 kilometer wind shear is very low compared to Monday. And another thing, this is camera people will like this part, is if you see where I did the yellow, basically pointer arrows in the two different directions, one pointed to 59, the other one pointed to 78. That's the temperature dew point. That's a lower dew point, which means lower humidity, which means less haze when you're looking at a couple miles distance for the view of the ship. Now, the other thing is clouds. Yes, I know I talked about a couple polka dotted clouds basically being around for Monday. Now, on Tuesday, we're still going to refine the cloud forecast. There still could be some lingering clouds because the front's kind of sliding into the Gulf. You can have overriding moisture that comes over that cold front, that cold dense air, and so you can still get some of those clouds. So we'll redefine that a little bit as it gets a little closer. It still looks like it'll be broke up enough that you'll have a mixed bag of clouds being out there. But now, real quick, I want to just talk about Wednesday. Wednesday, we actually have a very strong cold front that comes through. And that cold front a very strong cold front will blow through on Wednesday. And with that cold front, the winds we're talking about, winds probably 30 plus miles an hour out of the north. So to me, as wind shear environment is concerned, I don't think they're going to like Wednesday for flight. So out of all 3 days, to me, the best day would be Tuesday, or forecast wise for a flight would be the best day.
Right.
Monday, borderline. So I feel confident to say that just looking at the meteorology aspect of this, I think Tuesday would be the day that their meteorologists there are probably saying, hey, this is probably the better day. We're within thresholds.
Makes sense. Well, I mean, really quickly, if we just explain why shear matters, because I have a visual aid. If the wind is going like this, and you're ascending, or descending if you're a booster, hey. If the wind is going like this and then rapidly changes direction, that, it's pushing the vehicle around, which is not good, especially during the critical phases of landing, right? That's what we're talking about when we talk about shear.
Exactly. I'm glad you had that example there to point out the wind shear, because yes, you don't want wind direction coming in different angles and pushing it all around. When you want it steady to come down, I mean, that's a very precise landing it has to occur to. So yes, if I was on their team right now, I would be telling them, hey, Tuesday is probably a better day. Monday, there's still a little bit of time for the forecast to change just a little bit for Monday, but Tuesday's been looking better and better.
All right, well, I appreciate your diligence, sir. I know this is sort of your ball of wax, and you keep a track of weather, you're storm chaser, all of this, so your expertise is greatly appreciated, especially as all of us nerds, descend on the area and get ready for a Starship launch. So thank you so much, Adam, for the update. Hopefully we get some more clarity in the next day or two in terms of what's going to happen, if it's going to be Monday, if it's going to be Tuesday, what's going on. Obviously, if they do some sort of wet dress rehearsal on Sunday, well, they're not flying Monday. But yeah, all right. Special guest time. Are you guys excited? We have a special guest. Is the camera going to... Special guest, us.
I don't know. When's the special guest going to show up? There's too many cameras. Like, what are we supposed to do here? I think we're ready to hop into talking about the acoustics, aren't we, Jack?
Yeah, this is really cool. We have various plots around Starbase where we put our live cameras, And one of the things that enables us to do is host really interesting science. So let's go into it.
All right. So we've got with us our special guest. We should probably introduce him, I guess. It's Dr. Kent Gee from the Baylor. Oh no.
Oh no.
Oh no, from BYU.
Big 12 rival right there.
Acoustics, the physics department, right?
Yep.
And so y'all have done a lot of different research on rockets. You have a special system that you got, you put around rocket launches, different areas, different distances. You've done it with SLS, you've done it with other things like Falcon 9 and stuff like that. But for the first time on Flight 5, you came out and visited us and did some research on Starship.
That's correct.
All right. So tell us a little bit about how that works. Like you've got these devices, you're recording it. Clearly, it's not like something I'd buy off eBay and like toss out in the field. How do you record the noises?
Yeah. So we use scientific grade instrumentation, right? The same equipment that I would use in the laboratory, right? And then we ruggedize it. Put it in Pelican cases, weatherproof it, make sure it's all going to survive the temperatures, water, things like that.
Rainstorms at the Cape.
And then we put it out there and do our best to make sure we get the data.
Gotcha. So we're not just getting like little lapel mics or cheapo microphones. These are like scientific grade, if that's the right way to say it.
Yeah.
Mics, you deploy them out in the field. How do you choose where to put them? Do you put them like underneath the rocket? You put them far away? How do you come to that decision?
As much as I'd want to put one under the rocket, and I'm happy to do so, as long as somebody else foots the bill. But we basically try to just find locations that match the purpose of what we're doing, right? If we're trying to measure launch pad environments, obviously we're closer. We're trying to surround the pad and look for areas where there might be reflections or sound coming back from different directions along the pad. If we're more for community noise concern, then we're out in the much greater distances.
Gotcha. So it's not just one microphone you put in one place and you're like, oh, is this loud from here? You actually put multiple sensing units, recording units, sort of all over, and it just varies based on the pad. Like, I know y'all did a lot of research with SLS.
Right.
For SLS has the flame trench, which goes in a specific direction.
Hey,
so maybe.
Hey,
I said the thing. Maybe some of the microphones are downrange from the flame trench, some of them in the other direction. Then you can compare. Does that flame trench focus the sound energy in one direction or another? It just depends on what you're doing.
Right. Yeah, we do try to distribute both around the pad, right? For SLS, for example.
Yeah.
Right. We had microphones north, east, southwest. Right. About our closest distance was about 1.5 kilometers away. Right. So about a mile. Right. A mile away from the pad, and then we were able to get some sense of how symmetric was the noise.
Gotcha.
Coming off the rocket.
So this was, you were out here for Flight 5. You put out quite a few sensors. How many sensors did you get data from for Flight 5?
We got data from 8 sensors.
8 sensors.
Ranging from about 10 kilometers to 35 kilometers. We didn't have a lot of notice, right?
Yep.
Drove 1,500 miles in a day and a half, right, to get down here, and we put out what we could and got some data.
Gotcha. So got data from all the like around the areas.
Right.
I know you had stuff up on South Padre Island. You had stuff over in Brownsville. There was just a various range, but it was that sort of longer range out where the communities are, not necessarily right next to the pad, right?
Correct. Yeah.
So for Starship, that was a little bit different. SLS, like I said, has the flame trench, has its deluge system, yada yada yada. Starship has that OLM open non-trench design. So was this the first time you had recorded acoustics on a rocket like that? Or are there things comparable to Starship there?
Yeah, I think it's probably the first time we've measured something like that, because even with Falcon 9, right, which has kind of a symmetric nozzle arrangement, you still have some sort of trench, right?
It sort of goes in a direction.
So it's directional as it lifts off the pad.
Gotcha.
It's really interesting. You should try and see if at some point you can get out to Slick 2, because that is another rocket that launches on a sort of a little stool thing. There is a trench, but I immediately thought of Delta 2, which obviously no longer flies out of Slick 2.
Unfortunately.
But Firefly flies out of there now, and it's very much, the rocket is elevated above sort of the trench. So I don't know if that would That'd be interesting.
Yeah.
One of my favorite things about what you guys are doing is that you're collecting data from all types of different rockets.
That's right.
So you're able to sort of compare and contrast.
Yeah, it is an exciting opportunity, and we actually have measured the Firefly Alpha launch.
Nice.
We're still analyzing the data, but we've collected it a couple times, and we've done Delta IV Heavy, Falcon 9. I mean, lots of opportunities to compare rockets from different configurations.
Gotcha. So let's talk about Starship specifically, right?
Yeah.
First time we had these scientific quality microphones recording
That's
this
right.
information. You had a paper, a letter, I guess, that
Yeah.
came out today, like super fast track on the paper, right?
Yeah, we got home from that last launch, and in 10 days we analyzed the data, wrote a paper, and really grateful to the academic journal. For those that aren't familiar with academic journals, you don't publish a paper in a month, right?
Right.
It just, you have to have people review it, and it has to go through, the whole editorial process. But because of the interest in Flight 6, the journal was interested in fast tracking it
Getting it
through the
out.
review process, get people willing to review it quickly, and so we got it out the door just in time, right?
Yep, and there should be a link. I know the moderators and stuff like that have a link in chat. I put it out on X as well. If you're interested in reading through the actual paper, we're going to give you the link to that. We'll put it in chat, and you find it on the X post as well, right? So you can read everything because it's an open access.
It's open access.
That's
We've
the thing.
already paid the fee. You guys are welcome to read it.
Instead of being like behind a paywall or something from a scientific, sometimes that's the thing with scientific
Yep.
journals, right? This is open access, so anybody that wants can click the link and read the actual results of the paper.
right.
But there are sort of two things you're looking at here, right?
Mm-hmm.
We all know the whole thing with Starship and the environmental assessment and that sort of thing. So in the paper, you'll find some information about the predictions
right.
about Starship's launch that were filed by SpaceX with those environmental assessments in the FAA findings and stuff like that, and then the actual data that you recorded. So take us through some of that, and while we're talking about it, tell us how that actual data you recorded compared to the predictions that SpaceX sort of came up with that acoustic modeling.
Right. So in the environmental assessments, there's two aspects to the noise, right? There's the launch noise,
Right.
which they were, which is the rumble, right?
As opposed to
During
air
liftoff,
conditioning noise,
right?
if you can hear that
Yeah.
behind us here.
Just kicked in. But also, the reason why we drove, 1,500 plus miles down here so quickly is because it was going to be the booster catch attempt.
Yep, coming back for the first time.
Right, and that was going to be the first one, and we said we need the sonic boom data.
Yep.
And so that became an opportunity. And so the paper goes into both aspects.
Okay.
Both the launch noise and then the fly, we call the flyback boom.
The flyback boom.
Yep.
And the bonus for the hot staging ring.
Yes.
Apparently this hot staging ring made noise too.
Yeah, surprisingly, I would never have guessed that you would get a sonic boom from a supersonic cylinder,
Tumbling piece of
tumbling through space, down from space.
World's most inefficient frisbee.
That's right. Yeah, but yet it generated a sonic boom that was audible in Brownsville.
No kidding.
So anyway,
Looking back at my video of myself and everyone at our river lot, where I believe you guys also had some microphones. We had some of those folding chairs, like a little Walmart beach folding chair kind of things. The fabric seat back of all of those, when the sonic boom hit, you can see it move like a speaker cone.
Yeah.
It's
It's not
insane.
like pants, but it moved the chair fabric, I guess.
Also, yes.
Yes.
yeah.
But it's wild to me how incredibly loud super heavy sonic boom was compared to even a Falcon 9 RTLS from 2-3 miles away.
Yeah, no, and I think that's so. There's the two aspects of the noise, and then there were predictions made in advance, right,
Yep.
that go into these environmental assessments. And so we said, okay, we want to get something out quickly so people have some information to start going on. What's the most impactful thing we can do?
Sure. Like scientific data.
Scientific data,
Yep.
right? There's a lot of other things we can do with the data, but as a starting point, we said, how does it compare to the environmental assessment?
Right.
Where are we starting?
Which are the models, like
The
you have
models,
equations or whatever.
Right.
You think how much it's going to, how loud it's
That's
going to
right.
be.
Yeah, and so from that perspective, right, we were able to go through. In these environmental assessments, they have different ways of quantifying the sound.
Okay.
Right? Both the launch and the sonic
booms.
And so we went through and did a comparison at each of those, straight from the data. And what was interesting is they actually updated the sonic boom predictions, the environmental assessment, the day before the launch.
The day before the launch.
The day before the launch. October 12th.
Okay.
There was a new document that dropped an update
kidding.
to it. And so what we put in the paper was like hot off the press.
The
new
most
data,
recent.
new model that was like, less than about a month old, right?
Gotcha. So
it's already out there.
How'd they do? So let's start with the liftoff noise, the rumble
Sure.
and crackle as the rocket takes off.
Right.
We were measuring, again, the further away distances. We're not doing close-in distances here.
Yeah.
But hey, look, it's all sorts of things.
Yeah, well, let me go through this little figure here. And so what we're doing in this paper is we said, okay, we're going to look at the liftoff noise, we're going to look at the sonic boom, and we're going to compare it to two other vehicles of interest. You guys have talked about SLS already on the show, right? So we made noise measurements of the Artemis 1 launch, and we said, okay, at the time, that was the most powerful rocket ever successfully flown. Right?
There you go.
Gotta give credit to the N1.
The
Right?
N1 is in there. Yeah.
I always have to say the word successful.
Technically
right?
correct.
Right. So anyway, you have SLS, right, which is the most powerful rocket ever flown before Starship. So that's a useful comparison. And then second, you have the most launched vehicle, right, and most often launched vehicle, which is the Falcon 9, which has a cadence, a launch cadence right now that's similar to what they're hoping to achieve with Starship. Right. That sort of 100+ launches per year out of the Cape.
Okay.
Area. So that's what we're doing here. And there's the scale relative to the BYU Acoustics American football field, right? But just to give you a sense, and then on the top there, it's got the relative thrusts in meganewtons, and you can go convert that to pounds.
Really quickly, it's remarkable to me how small Starship makes SLS.
It's incredible, right? And of course, with these things, it's so hard to get a sense of scale. You just look up and you're going.
That's why they put a banana on this one.
That's right. Standard banana for scale.
Standard banana for scale, yeah.
So, and also, I mean, you see a Falcon 9 up close and you just think that's enormous. And, it's just dwarfed by Starship. And so then those figures talk about, on to the right there, those are photographs that just show different stages of the launch of interest, right? The liftoff, ascent, the flyback, and then the landing.
The landing catch, right.
Right.
Okay. And I think we have more graphs and stuff to show. But we started measuring the data.
Right.
And at sort of let's talk about South Padre Island. Right? You can watch, the public can watch from here. There's the graph.
Yeah, if you look at that little graph there, so at South Padre Island, there were two stations itself.
Yeah.
Right? Station 1 listed there, that was on top of the Margaritaville Hotel, which is a little bit north. Yeah, thanks for the access, by the way. But a little bit north of where you would have the people there at the park that are
right. It is Isla Blanca where the public can watch from. Yeah. So a little bit further than the closest the public can be.
That's right.
Unless you're going out to Rocket Ranch or something like that.
That's right. And so then they have another one that's about 16.5 kilometers.
Gotcha. But populated areas. Right. I mean, people live there. There's buildings. There's condos. That sort of stuff. Right.
Okay. So can we? Did we touch on what the prediction for launch was in the EA versus what it actually was?
So
let's talk about SPI.
Yeah, so maybe this just gives people a sense. We were in Laguna Vista, we were in Port Isabel, we were out there in Brownsville.
Up the ship channel there, all the way up to 35 kilometers, Station 8.
Yeah, we had one station out there, and I'm glad we put something out there because it really gave us a sense of how it's changing with distance.
Okay. So let's start at like 1 and 4, 1, 2, and 4, that sort of area.
Right.
How did the modeling and the environmental assessments compare with the actual data that you recorded?
Right. So so there are different ways of quantifying sound.
Oh boy.
Right. I know. And this is going to be
decibels, right?
The decibel.
Simple. It's decibels.
Hey, at least it's not radiation. It'll be like Rontgen, Remkin.
What's unfortunate about the decibel is that it's like it can mean very different things depending on what metric of sound you're after. But they're all called decibels.
I just felt like a decibel was a decibel. It's like, how many chainsaws loud is it?
Well, we can say, how many feet in a mile, and then we can say, well, are we using your foot, my foot, right? Jack's foot. I mean, we can. It's all It's all a foot.
Yeah.
But it depends on what your measurement is.
What do you mean? Like whose
What
foot
do
are
you-
you
what do
using?
you mean by this?
Whose measurement scale are you using? So a decibel isn't a decibel.
Right, and so there's a standard measure for each type of sound metric.
Okay.
But they're all called decibels.
They're all called decibels.
Right. And
Okay.
so when we talk about that, so that's the precursor. When we talk about the environmental assessment versus the measurements, the agreement with the data depends on the metric. Some metrics are pretty close, and other metrics are not.
The most important thing is to agree on the units up front,
Right.
because you can't just say, oh, decibels. Like you can't just grab a decibel thing and, well, is it the right type of decibel? Is it the right unit of decibel, or whatever the right way to, the metric of decibels? I don't know the right way to say it, right?
Well, so I mean, and just for one example there, right, we can talk about how much power, sound power, an object puts out, right?
Right.
That's decibels, right?
Okay.
And you can talk about, our SLS put out about 202 decibels of sound power. But you'll never measure that because you're measuring at some distance, right?
Right.
The sound power is the accumulation of all of the sound energy, but then you measure it at one point. Right.
Okay.
You can talk about how much heat your furnace is putting out.
Right.
And then you can talk about the temperature at different points in the room.
Okay.
And that sound pressure is what we hear and what we measure, and that will always be less than the total sound
Than the
power.
actual power that it's putting out.
Right.
Okay, gotcha.
Okay, so when we start talking about those metrics, then. We can talk about those. How does that sound pressure level during launch? How does it change with distance?
Okay.
Right?
It should go down over distance.
It does
like
go
the
down
further
because
you
it's
are.
spreading out, right? Just think of like your radiation, from a light from a light bulb, right?
Yep.
The farther away you get, the dimmer it's going to appear to be.
It's the same thing with solar panels. So the reason we use like nuclear generators on some probes is because the further you get away from the sun, the less photons you're catching, right?
Yeah.
The sun only makes so much power, and it spreads out in a huge, massive sphere. So the further away you get from the sun, the less power the sun has. I don't know if it's power actually. Energy the sun has made has reached that point.
That's
and
right.
sound is the same thing. The rocket makes so much power, but as you spread out, that power is less dense.
That's right.
I guess.
That's right. Spreading over a greater area.
Spreading over a greater area, which there you go. All right.
And so same physics.
Okay.
So anyway, so then the question is the predictions, right? They have predictions that decay with distance,
right?
And then our measurements also decay. It might be easier to show a graph if it's helpful.
Let's see what Kevin can get for us here.
Bingo.
Okay, now that's a graph. We'll get to your answer because I'll show just briefly what's on here.
Okay.
Okay, this is at one of the stations. This is the station in Port Isabel. Where we had somebody standing there.
Okay.
And so that gray part there on the top where it says pressure in pascals, and then it's all in time relative to liftoff, and so it goes out to 500 seconds.
Yep. Okay.
Okay, so it takes some time for the sound to reach there.
Right.
Right, because sound travels at about about a third of a kilometer per second.
Right.
Okay, about 340 meters per second, and so it takes a while to reach Port Isabel.
You can see that in the graph there, like on the bottom graph, time relative to liftoff.
The bottom is two different metrics of sound, right? What we call, the unweighted or Z-weighted level, and then the A-weighted level. Okay, and those are different metrics of sound, and I'll talk a little bit about that in a minute.
Right.
But they both jump up, they reach a maximum, and then they slowly decay.
You can see the rocket getting further away.
Right.
It's like it takes a while. In that, look. There is empirical evidence on this graph that we don't talk over the rocket launch. Because you see where it's like 25, 30 seconds, there's no audio reaching the microphone yet?
Yeah.
We're still talking.
Oh, yeah.
And it's because the sound hasn't gotten to us yet.
Yeah.
Chat.
You're hard pressed to talk over a rocket launch, especially where you guys are viewing these.
That's true. But then it jumps up and you see the sound sort of crescendo and then taper off over time, right?
Yeah. And so then in that gray waveform at the top, that's a time recording of all the pressure fluctuations due to the sound. And so it grows and then it decays and then becomes quite small. And then, right, I can't even, whichever blue arrow there, I guess.
Yeah. There we go.
At the
We'll
top,
enhance.
Right, thank you. The blue arrow at the top there, that is the flyback sonic boom. And then we've zoomed in. And you can see that there is this shock, then there's this ramp, and then there's a shock, and then a little ramp, and then another shock. And we call that a triple boom.
So Super Heavy has a triple boom.
It does. It does.
Really?
They're completely different shapes.
And, you know, feel free to invite us back.
Okay.
We can explain. We have a paper that's under review right now, academics, right? That will describe conclusively why it produces.
Why
the
it
Falcon
produces
9,
three.
The Falcon 9
That's
produces
fantastic.
a sonic boom.
Because we've talked about
Oh,
this
I know.
All the
on
time.
the stream. We
Yep.
say, oh, it's going to be a boom-a-boom.
We
Or it's a
are,
boom-boom. Or,
yeah, you just wait a little bit. Just hold on. It's a teaser. But the triple boom from Falcon 9 is not exactly the same shape as from Starship.
Okay.
And so we can, there's reasons, there are physical reasons for the difference related to the geometry of the vehicle.
And we're still looking at the blue.
The blue one on the left.
The blue highlighted there.
What's that green guy over there?
The green one at the right, that is the hot staging ring falling into the ocean. What is it? They said somewhere about 8-10 kilometers off the
Yeah, it was
coast.
just offshore.
And that one produces more of the traditional, they call that an N wave because it comes up, then there's a ramp, and it comes down. So the one on the left, we started calling it, trademark, an M wave, right?
M wave.
Because there's three shocks.
That's right.
But it's also interesting is that you can almost tell that it fell into the ocean and had to travel through more of the atmosphere, more of a turbulent atmosphere.
How can we tell that?
Because it's a lot more wiggles to it, right?
It's dirtier.
It's dirty.
Whatever.
That's right, and that's due to atmospheric turbulence.
Really?
Little fluctuations. It travels slightly different paths, reaches the microphone, and it just makes it a little bit wigglier.
And you can see it's like a marked difference. The blue N or M.
It's like
I
I couldn't believe when we looked at the data how clean it was. It was just like, I mean, you would be hard pressed to draw that.
Kidding.
As clean as what we measured there.
And so another thing to look at there is the scales, right? I don't know what the units are, but
those
it says
are pascals.
Pascals, 400, not quite 400, in the mid 300s it looks like, on the flyback sonic boom, and the hot staging ring was just south of 40.
It's small.
It's small.
Yeah,
but you detected it.
It's detectable, and it's audible as a thump.
Yeah.
But you're not. It's quite low.
That's not moving anybody's pants.
Can I reveal a secret though? Because it kind of did. Because when I heard that, we didn't have visual on the hot stage ring, and I'm sitting there at the river lot, 3.6 something miles away, right on the blast danger area. So I'm like, I have 16 seconds if this thing goes pop to get into the brace position. Like that's what's going through my head, and I hear that boom from the hot stage ring, and I immediately thought, oh god, the booster's cooking off. And I rolled my camera again to make sure if it exploded, I would have video, whole 9 yards. But obviously none of that happened. And then later on, somebody was like, I think that was the hot stage ring. And I was like, holy cow, was that the hot stage ring?
Let's put that graph back up again real quick, because I can see chat asking this question, right?
Sure.
How do you know, I think I could answer this, but how do you know that's not the sound of it splashing into the ocean?
Oh.
That doesn't look like a splash, does it?
No, a splash would have a very different character to it, because it has to, if you want to think about a splash, right?
Yeah.
It has to displace all that water.
Right.
And that splash, right, it takes a while for it to come down, reach terminal velocity. It displaces all that water, and then the water has to kind of collapse back on itself. And that is a much slower process on an acoustic scale, right? I mean, that is 1 second of data.
So
that window is
1
1 second of data. So this is happening. Yeah.
Gotcha. And it's the same. It's the classic sort of shape there. It's got the peak, then it goes down, then it goes back up
very
again.
Similar to your classic, which is crazy. It's very similar to your classic aircraft, like sonic boom.
Like an aircraft sonic boom.
And yet, I mean, this
it's not
looks
shaped anything like an aircraft.
Aerodynamic or whatever.
Yeah.
And so there's probably all sorts of things that could be looked at on that. But this was a short paper. We didn't actually dwell on that.
This was the fast turnaround
But we wanted to just show it, because it was. I mean, people would be like, wait, what's that spike? And we didn't want to cut it off. And so the other two curves in there, that's the launch noise. That's kind of the maximum launch noise period.
Right.
And you can see how it's kind of leaning, right? It's really sharp rises, and then like little ramps and sharp rises and ramps.
Okay.
And so those sharp rises, we call those shocks.
In the orange and maroon.
And then the red is the when it does the retro propulsion.
That's the landing burn.
That's the landing burn.
The maroon or red is the landing burn, and the orange is the liftoff. I see the arrows.
Surprising how large that is in amplitude.
Yeah.
and because they don't have as many engines firing during that. But yet, there's got to be something in the physics of it going against the direction of travel.
It's almost like it's pushing the sound towards
Something.
It's building the sound up instead of going away.
We noted it as an interesting observation, how high an amplitude that is.
The scales on those two graphs, the two top graphs, have the same scale on the y-axis.
They do.
They're both 100. Is that Pascal still?
100 pascals.
That's the same scale.
And
there.
just 100 pascals though, just so people understand, right?
Yeah.
We perceive that as loud. 100 pascals is 134 decibels.
Okay.
Right?
What is that, like chainsaw jet engine?
No,
like,
that's jet engine.
Okay.
Right? That's like jet engine type levels, those kind of peak levels. But that's 1/1000th of an atmospheric pressure, right? I mean, it's 100,000 pascals is atmospheric pressure.
It's loud to our ears, but it's not a lot of physical force.
Yeah, we really perceive small changes.
Okay.
And so, but the other thing I wanted to point out is those sharp rises, just like with the sonic boom events, that's what we perceive as crackle. It's because
I love this.
It's because I spent my doctoral work and I spent like 15 years studying what's called jet crackle.
This is what you do.
I studied jet crackle.
Yeah, this is fantastic.
And so
Everything I ever wanted to know about the sound of a rocket launch.
so up close, it's very, very sharp. And then as you get really far away, you get these losses in the atmosphere.
Right.
Some of the high frequencies get absorbed. And so then it takes a little bit longer, right, for the sound, for those rises to occur. And then so we go from hearing crackle, 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 like really sharp, to more of a bang sound. And then that thumping that you hear in the atmosphere, right, if you've heard of the rocket launch, that thumping is those individual shocks arriving when that thing's now like 100 kilometers away.
No kidding.
But it's gone through all of that atmosphere, and so they're weaker, and so you kind of get it as a thump.
Really?
And so you get, so that's I really wanted to emphasize that.
Yeah.
Because rocket noise is such a unique sound. There's really nothing like it.
Right.
When people say, well, describe what it's like. Well, it's like thunder. No, it's not like thunder.
No,
It's not like thunder.
Jack knows what I like to say. It sounds like it's ripping the atmosphere.
Yeah.
Like the atmosphere is being
It's like
torn
literally
apart.
tearing
In fact, the
air
very first
asunder.
paper talked about like the sound from irregularly torn paper.
There you go.
Or they talked about water added to extremely hot fat.
Okay.
Yeah, the
Like a
British,
popping or crackling
the
noise.
British had a way with
Okay,
words.
couple things here real quick, if I may.
Yeah.
First off, Dr. Holly she's in chat, she wanted us to know that her students' data, her students' air pressure data, match the BYU data.
Nice.
That's pretty cool. I love, like, more science, more better. So
Absolutely.
Also, we did have a question from...
These were the high school students,
Yeah, the high school
right?
students.
Yeah.
Fantastic.
We have a question
Shoot me an email.
from Six String Simpleton asking, what permissions are necessary to put a temporary experiment at Danger Lot? Well, that's not our spot, but we have spots.
Yeah.
So reach out to business at NASASpaceflight.com and reach out, because I love this.
Yep.
I love that we're able to learn so much from all of this.
It really is cool.
We do have that other graph that you were talking about.
Oh yeah, and I think
the
that's the
distance
one.
graph.
I think that's the one we really want to get to.
Let's check it out.
Because this one, you asked right at the beginning about the metrics,
I did.
right? and we had to set it up a little bit.
We have to set up the background so you understand what we're talking about.
And
That's why we've
there
got
is
you here.
one more piece of setup that I think we should do. Okay.
Okay.
So most often when we talk about sound, when we talk about people, we talk about something called A-weighted levels.
Okay.
And these are baked into federal regulations and community noise regulations. Everywhere you look, we talk about the A-weighted level.
So if there's like a noise ordinance for having a loud party, when they use that scale, it's usually A-weighted?
Yes, and let me explain what A-weighting is.
Okay.
So we don't hear all frequencies, all pitches, with the same sensitivity.
Equally, right.
There's a sweet spot where we hear it really well, and it's particularly annoying to us.
Gotcha.
But we don't hear the lowest frequencies as well, and we don't hear the highest frequencies as well.
Okay.
Okay. And
the ear
and it has nothing to do with age, right? That's just the human ear.
Okay.
And so they built in sort of a weighting, a filter network into it to diminish the importance of the low frequencies and the importance of the high frequencies.
So they
roll them off.
It's really what people, what impacts or what affects people the most, what people perceive the most.
That's right.
Versus this is the raw physical data. Well, our ears don't work that way.
That's right. So when I say unweighted or Z-weighted, I'm saying that's the raw physical pressure data.
Physics.
Right.
Okay.
Regardless of the frequency at which it occurs, right?
Okay.
And that could be infrasound, below the range of human hearing, or ultrasound, infrasound, above the range of human hearing, and we could just talk about pressure and have it be the same.
Right.
Okay. But that's not connected to our human
How
experience.
we perceive it.
So A-weighting is an attempt to connect it to the human experience.
Okay.
But I'm going to mention the caveat now, and then we'll talk about the data, is that A-weighting was designed for sounds between a whisper and conversational speech.
Oh.
Back in like the 1950s. And it's now in all these regulations, and every time I publish a paper and I use an A-weighted level, I will always say, we have no idea if this applies at all to human perception or animal perception, right?
So we're like over the scale now. We're out of bounds.
We're out of bounds, both in terms of the character of the noise as well as the amplitude.
Okay.
And so, that's the caveat. But now, why did we put it in this paper? Right?
Okay.
Why did we put both in this paper? Well, it's because that's what's in the environmental assessment.
Right.
That's what's used.
So how do you compare it?
So we have
that's
to
what they have
compare.
in there, so that's what you
We're
use
doing
here.
the comparison.
Okay. Good to know.
We're ready to.
This is fantastic
We're
setup,
ready
by
to
the
show
way.
the graph.
Chat,
now.
is everybody experts in acoustics now, so we can look at the graph?
I'm looking at chat, and all I want to quickly say is everyone is so thankful right now for the nuanced discussion. Like we're all nerds here, and we're all trying to learn more about everything pertaining to Starship and all rocket launches. So everybody is appreciating the nuanced discussion. Please don't let me hold you up. Continue.
We will have you back for more discussions, by the way, because we need more stuff like this.
Well, it's great. I mean, I felt like it was important because these are the types of discussions that I'm having with a lot of people, both in, rocket companies,
right?
Federal officials, things like that, right? I have these kinds of conversations, and it's really important that people understand that these metrics, we all call them decibels, but they really are meaning two very different things.
Right. Okay.
Okay.
Gotcha. So graphs.
The graphs. Okay. Wow. Where to start? Okay. So the first one on the top left. This is the maximum 1 second. So if you average the sound level over 1 second, the maximum sound level over 1 second unweighted. This is the raw physical quantity.
Physics. Okay.
Right. And then now the distance is put on a logarithmic scale.
Okay.
So this, if you scroll down to the very bottom for just a second there, you'll see that this ranges from 10 kilometers out to 40 kilometers.
The scale on the bottom goes up all the graphs.
It goes up all the graphs.
Okay, cool. Very efficient.
And so it gets compressed though because it helps you actually represent the data and see it more clearly, because would be like a roll-off, like that looks kind of an exponential kind of roll-off, it now looks like a straight line.
Right.
It makes it scientifically easier to see.
Okay.
Okay, so the circles on the top left now.
Enhance.
Those are the those are the measurements. Okay, from the 8 stations ranging from about 9.7 kilometers out to 35.5 kilometers.
Okay.
And then the gray dashed line, that's a fit just to the data. That's our best,
to the actual measurements.
Yes, to the actual measurements. Now, we had to pull out from rather coarse contour plots in the environmental assessments.
Right.
They're not really highly resolved, but we were able to kind of make do some math and get a fit to those. Those are at the actual measurement locations, and it's not all perfectly symmetric. That's why there's noise in them. But those are the diamonds.
Okay.
Okay, so now this is one of the metrics.
Right, and this is the raw physics data.
Everyone could look at this and go, oh, there's a difference.
There is definitely a difference.
They start off similar, right, at 10 kilometers. A difference of a couple decibels, right, is actually pretty good.
Okay.
And you're in an outdoor environment.
Weather and humidity.
That's pretty good. And one of the reasons that they use the decibel is because 1 decibel, 1 dB, is sort of the amount of change a human can detect.
Okay. I didn't know that.
Yeah. So that's kind of what they call the just noticeable difference.
Is 1 decibel.
Is 1 decibel.
Like
on the order. Yeah. It depends on frequency and amplitude, but it's about 1 dB. And so you're not far off at 10 kilometers.
Right.
But then you start seeing differences.
The further out you get, the more the blue circles are higher than the diamonds.
That's right. And now you know why I was very grateful we put the one at 35.5 kilometers, because without that data point, we wouldn't know, we wouldn't be able to see the degree of difference. And those are 2 different trends.
So,
and again,
so the level of this pascals, is that Or is this in decibels? Sorry.
This is in decibels.
Okay, so
This is
level
in
of decibels
unweighted decibels.
Does,
Unweighted
does
decibels.
not
Unweighted decibels.
drop off as fast as predicted.
Does not drop off as fast as predicted.
Interesting.
Okay.
Especially that one that's way out there.
Right.
It was just north of 109,
Yeah.
but the measured was just north of 118, 119.
That's right.
So 10 decibels roughly. I'm reading a graph, right? Okay.
Okay.
But again, let's reiterate the point. You didn't have like a table with these numbers in it. We just had the rough. Remember the map, y'all? We used this in a couple of our videos.
Yeah.
And it had the contour lines, and it was like, oh, about this, about this, about
You
this.
have to go in and pick off the point and do some math
Do
to
some
kind
extrapolation
of
or
extrapolation,
yeah,
interpolation,
exactly.
right?
Interpolation,
to be able
yeah.
to be able to get those.
Okay.
And so there's a little bit of uncertainty on those, but
Sure.
but not 5 or 9 dB.
Right.
So that tells us something else is going on besides what's being predicted.
Okay.
Right? We have a challenge. Now I don't know exactly how the model is being produced.
Sure,
Right?
okay.
I mean there's some scientific papers and some reports about the model that goes in that they're using to do those predictions, but there's a lot under the hood that I can't speak to.
It's not in an open paper that you can just click on and read like this one.
No.
Link in chat.
Mods, put it in chat.
Put the link in chat.
It's a really interesting paper.
It really is.
And honestly, we tried on this first one to make things like comparisons to aircraft and
Right.
Concorde and things like that. So that
What did I
people
read?
have
It was
something to-
like at Port Isabel, it was like comparable to a rock concert.
So let's
or something
actually
like
go to
that.
the top right one.
Okay.
That's a good segue, actually.
It'll scoot to the right here momentarily, but
Okay,
we have
so
our
the
next
top
graph
right
over
one is the same idea, the maximum level, but from an A-weighted scale.
here. The weighted for human perception,
Weighted for you.
kind of.
We got
but not
rid
really.
of we got rid of some of the low frequencies, got rid of some of the high frequencies, and the values are lower. Okay, and that's because you got rid of a lot of the energy.
Right.
There's a lot of rocket noise. Energy is at the lower frequencies.
That we don't really perceive as much as
Right.
other noises in our range of hearing
Right.
that our voice would be or whatever. Okay.
Okay, now if you look at
that.
look at this one, right? Is that now there's scatter in the data.
Sure.
But if I'm doing a prediction model, I'm pretty happy
That's
with that.
pretty close.
Somebody should be like ecstatic that the A-weighted level, the
Yeah.
maximum A-weighted level, does match pretty well.
And that is what they typically, you said, that's what they typically use, the A-weighted, trying
That's
to
right.
put it in human perception with the caveat that maybe it's not perfect for things that are as loud as rockets
Right.
or jet engines. Okay.
So there's something wrong with the model, something right with the model,
Right.
compared to our data.
Right.
Now, every time you take data, though, the weather conditions could
Yep.
be different. We
Yep.
don't know what we
Need
have.
more
One,
data.
we have one data set,
Yep.
right?
Yep.
There's all these different changes that could occur. Okay, so now the second set of graphs. Oh, so let me actually go through this. Sorry, before we go down the graphs. Let me walk through those comparisons.
Sure. Yeah.
Okay, so somewhere in that 105 dBA range that's what we typically associate with things like chainsaws,
Right.
rock concerts, that kind of range. These are loud sounds.
Yep. Something you may be around, like the public
Yeah.
could experience that. If you're running a chainsaw, you should have on hearing protection, but I'm using a chainsaw for 30 minutes or an hour.
This is the maximum
This
1
is the
second.
maximum
right?
1 second.
Right. And we're going
Okay.
to talk about duration in a
Okay.
minute here, right? There's
I
other
keep getting ahead
metrics.
of things.
Yeah, I know, it's good, right?
I like this.
Sorry, this is nuanced.
No, this is
You used
fantastic.
the right word.
Like I said, we are all here. How many thousands of people? We're all here for the nuance.
Yeah.
So, okay, and then you move out to that, so that's like the 10-kilometer range.
Right.
You're
That
in
was South Padre, Port Isabel sort of area, the
right?
closest 10.
Right. So by the time you get to like 20 kilometers, that's Laguna Vista.
Right.
Right. That's your next town there. We had a couple of stations there, stations in between. Now you're talking more like snowblower,
Okay.
table saw, loud shouting. Like if I'm yelling at you,
Okay.
that's actually the A-weighted level 20 kilometers away.
Really?
Max talks.
Yeah.
Like the way Max always talks.
So that's a loud event. Well, I mean, there's a peak in that,
Yep,
right?
yep.
And you're measuring the peak.
The peak. This is the max.
Yeah, it's not the whole event, right? So that's loud shouting 20 kilometers away.
No kidding.
According to this metric, right?
All right.
Okay, and then when you get down to 30 Brownsville
That's
now,
all the way
right?
out in Brownsville.
35 and a half kilometers away. Now you're talking like hair dryer, let's see, things like hair dryer or
Yeah.
vacuum cleaner, right?
Hair dryer or vacuum
It's
cleaner, okay.
those kinds of levels. But that's where I want to illustrate, right? What you hear at 35 kilometers,
right,
doesn't sound like a vacuum
cleaner.
Sound like it sounds completely different
than a vacuum
So much
cleaner.
of that energy is that very low frequency energy, and that's why again we caution about how useful are these metrics.
Right.
We don't even know what ruler we should be using right now to quantify it. But
Okay.
But we got to start somewhere.
We use the ruler we provided.
A weighting is at least reasonable, and that gives some sense in terms of the comparisons.
Okay.
Okay.
So, to summarize real quick,
please.
The raw physics in the upper left sort of under-predicted. Whoa, not that graph, but the previous graph. The raw physics sort of under-predicted what was recorded on that day, and you need to get lots of launches and lots of days, and you put all those together and see how the environment and the weather and stuff like that fits it. But the A-weighted in the upper right-hand corner was almost bang on. I mean, the little trend line that's in there is like right down the pipe. So that is fantastic looking. We have 4 more graphs to look at.
Yeah. Okay, let's keep going.
All right.
So we talked about this being like the maximum 1 second average level in there, right?
Right.
Okay, so
we'll go back to that one in a second. Stand by.
Okay.
It'll come back up, I hope.
So duration matters, right? You know, there's different ways of, hearing damage, for example, right? From a chainsaw. You use it for 30 minutes without hearing protection, you're in trouble, right? You're running the risk of hearing
You're an
damage.
idiot, is what you. I mean, I can say that.
You know,
should
being
use hearing protection.
exposed for 1 second to chainsaw level.
That's different than
very
using
different.
it for 30
So
minutes.
exposure length matters.
It's like the total effect on you versus the max.
Okay, so on the left of the middle plots, I have what's known as the unweighted sound exposure level, which is essentially the summation or the integration of the levels over time. All that sound energy
that reached you at that
is
point
summed up over the entire launch event.
Gotcha. And that's just measured. There's no prediction on that.
Because that metric doesn't appear in the environmental report, but we include it in the paper because look at how smooth that decay is.
It goes off.
I have a prediction model for that, right?
There you go.
Right? I mean, plus or minus 1 decibel.
Yep.
I can predict what the sound exposure level will be unweighted from a Starship
From
launch.
a Starship launch because you recorded the data.
Until I have other data that tells me otherwise. That's my model.
Right.
Right. And
No
so
kidding.
it's that's the physics, right? And again, those levels are higher because it's the summation integration of all of that sound.
All of that over time. And it's the raw physics, it's the unweighted, it's got a Z on it as opposed to an A on it.
Okay, slide to the right.
Over to the A weighted.
Okay. And this will be
this is fantastic, by the way,
Now this is.
By the way, Kevin appreciates the direction.
Okay, we're like waving at the graphs on
Kevin,
the screen.
I appreciate you.
It's like our voice-activated production here.
Yeah, I really appreciate you. Okay, this is another fascinating one. So A-weighted levels again are less because you've gotten rid of the low and a little bit of the high frequency energy.
Right.
Okay.
Whoa.
Remember how the unweighted max level was more than
higher.
was predicted. Look at the differences here. And we had to check these graphs like 3 times
Of course.
because we're like, wait a minute. Is this real?
Is this for real?
What's in the environmental assessment right now is the accumulation of all of that A-weighted sound energy is predicted to be much higher.
Way
than what we
higher.
measured. And again, our data fit a very clear trend line.
Yep. It's not like a bunch of outliers.
Their data have a trend line.
It's almost a similar trend line. I do wonder, maybe they put higher than expected levels in the EA because there's going to be versions of Starship with more thrust.
I don't know.
There's a lot of things going on. But if you go from a physics model perspective, you have one metric that works, and one that under predicts and one that over predicts substantially. The difference, is. It's like 18 decibels.
Yeah, I mean, all the way out, it's
at 35 kilometers.
Yep.
It's enormous.
So just to make sure we're translating this correctly, what was predicted in the environmental assessment was way higher than what was actually measured in this specific yardstick. Are we still in liftoff, or are we talking about sonic boom?
This is liftoff.
This is liftoff.
Just liftoff.
And this is the total sound exposure.
Sound exposure during the launch event.
Gotcha. So were they overestimating? Did they not have a good model? Whichever way.
I mean, again, without knowing what's under the hood, I think there's some challenges with the modeling process because it's getting some of the physics right, perhaps, but not other parts. But I just want to illustrate, when you say, I'm saying an 18 dB difference, right? What is dBA, right, on the A-weighted level? What does that mean, right? That's the difference between conversational speech which is around 60 dBA.
Okay.
And whispering, which is near like 40 dBA. Like that a 20
That's the
dBA difference. Talking versus whispering.
Like you can tell the difference.
Yes.
Humans would very easily
Yeah.
perceive the difference in
So,
that wide of a range.
You know, I mean, imagine somebody talking at you, 24 hours a day versus whispering at you 24 hours. There's just a huge.
My wife
huge
knows how that
difference.
is.
This isn't a psychology experiment. But anyway,
The A-weighted DOS sound exposure levels. There's probably a graph for that somewhere.
that's right.
It's not a good looking graph.
Anyway, so
It's actually higher than predicted.
So, I think this is important, but this is just one of the metrics that's used.
Right.
And so this one has a difference. And that's why we put the data out in the way we did, because we
Yep.
wanted to get this out as fast as possible so people have something to go on.
And again, reiterate, this is one day.
One
This is
day?
one launch. This
That's
isn't
right.
10 or 20 or 50 launches.
And
This
why
is
are we
one
sitting
launch.
here live?
Well,
Right?
because you're back at
Because
Boca
we're back
and you're in
here, we're back
Brownsville.
here in
Guess
Brownsville,
what?
yeah.
You didn't
So-
just come here to hang out with us.
As much as as fun as
Aw.
it is, right? This is great.
Okay.
Okay. So now I want to put into context, right? 10 kilometers. What we measure is between 110 and 115 dBA
Right.
sound exposure level.
Okay.
Now we had to kind of go digging in papers to find comparisons, but we actually found a European database that actually has commercial aircraft sound exposure levels. And this is great.
Okay.
Okay, guess you ready for this? The sound exposure level on the A-weighted at 10 kilometers is like a 777 extended range, right? Or a 747-400 or the A380.
Like a commercial plane.
Yeah, standing 200 feet away during takeoff.
200 feet away.
200 feet away.
Okay.
So 110 to 115 dBA sound exposure level
Yeah.
is like that sound exposure event. Now it's over a much longer period of time for the rocket launch.
Right,
If you're
right.
at 10 kilometers, right? That sound persists.
Now I
for
want
much longer.
I want to go and look because I can go to the Charlotte Airport overlook,
Yeah.
and I can see stand on the side and watch the planes land or take off. And I want to measure how far away I get to be from the planes. They're at the public airplane
Yeah.
viewing area.
You're not
versus
going to
the-
be 200 feet away,
Yeah,
right?
yeah. Well, it's pretty close, but I
So
don't think it's
you're
200.
gonna be farther away. And
Yeah,
so,
yeah.
But that's just to give you a sense of there's at least a little bit of data we were able to find that gave us something to compare to, right?
Gotcha.
Everybody at least has at some distance. I mean, 10 kilometers away from a commercial aircraft, right?
Yep.
Versus, oh wait, if I were 200 feet
away from the commercial aircraft.
that's close, right?
Yeah.
And you would expect to get a much greater level, and so that's kind of what the sound exposure levels are like.
Gotcha.
Again, that's not what you hear at one moment. That's just
It's the total
summation.
exposure, like
Duration,
running the chainsaw
level
for 15
plus
minutes.
and duration.
Yeah,
right?
yeah. It's like filling up the sound exposure bucket
Yeah.
or whatever.
Okay.
I made that up.
I think that's everything I got to
I
talk
don't know
about
how long
this.
we're supposed to talk in this
I
segment.
don't know.
We'll just keep going till we're done.
We're done to the sonic boom.
Okay, sonic boom.
So I'm done with launch noise, right?
Oh, that was cool. It just jumped down to the other one.
Well, okay,
Nice,
I'm
Kevin.
almost done with launch noise.
Okay.
But we'll talk about the Falcon 9's SLS comparison here at the end.
Okay.
Okay, so here's your sonic boom overpressure. And all I have to say is whatever they did on October 12th when they updated the document,
Yeah.
that was based on something.
It was
right?
based on something.
Right, because they dramatically changed
Right.
the predictions.
Okay, and the
look
predictions-
at the predictions and the measurement, right?
They look like their most
Yeah.
up-to-date predictions before Flight 5
Yeah.
are almost bang on what you measured.
Now the only difference is, we have nothing inside of 10 kilometers
Right.
for that data set, but that's where the biggest differences are. So that leaves us
Gotcha.
with a question. What happens at 10? If we were to do it again, would we see the spread?
Yep.
Right? And so 10 pounds per square foot. Got to love the units here.
That's the units on
PSF.
this one. Okay.
Okay. That's the typical measure when you talk about sonic boom overpressure. That's the maximum amplitude of the shock.
Right.
And 1 pound per square foot is almost 50 pascals.
Okay.
It's like 48. Okay, but so if you go into old reports, 10 pounds per square foot starts getting you into the range of like glass breakage. and
Okay.
things like that. Okay. Now that was like single pane glass,
Right, like old glass or
older
something like
glass,
that. Yeah, old reports.
compromised. There's things you can talk about there,
Yep,
right?
yep.
I don't know if there were any reports of glass breakage.
I hadn't seen anything. We know people all over.
Doesn't mean there hasn't been.
There hasn't been.
I feel like I'm connected enough to the community down here that I would know.
And we know a bunch of people right there in Long Island Village, the closest condos to the launch pad.
Now, and 10 PSF is not like, oh, you will have glass breakage, right? But
it's not like movie
there's this
sonic
probability,
booms.
right? The probability starts going up a fair amount when you get to those kinds of
This is
levels.
important because this is sort of like how much force is being absorbed or exerted on an object.
Yeah.
So that's why it's in
how many pounds
per
of push per
square foot.
Yeah.
You know what this graph tells me? I've been dreaming of a shot for a long time now, and it'll take a while before I attempt it because I'll have to be on South Padre Island.
Yeah.
But I want to shoot slow-mo of a launch framed so that by the time the sound hits me, I have some glass in the frame as Starship is ascending. So you can see the glass through the jello.
We should just put...
That would make a fantastic video at your riverside, right?
It's been in my head for literally years.
That would be cool.
Someday
and then we
I'll
should
shoot
mount. We should instrument it with some accelerometers.
Ooh, I love science.
There we go. Well, you put one kind of in the edge, and then you put one
so you
right
see
in the
how much
middle, so you get the maximum display.
We should put it on the solar panels.
Look at that. We're designing a science experiment as we sit here.
I drag the trailer down the road, and the solar panels look like a fluid when you're driving down
terrifying.
the road.
I can't confirm, and it is terrifying. In fact, I usually remove the solar panels before we drive down the road for that reason.
So yeah. Anyway, those are substantial booms, right?
Right.
And so we had people at some of these stations, right? We were out in parks and things like that, and so at 10.1 kilometers away, it was a park in Port Isabel. Okay, the launch noise set off, the maximum launch noise set off car alarms.
Right. That makes sense.
And then they turned them off. Right? The student Noah, who was there, he's like, people turned off the car alarms, and then the boom came. They set them off again.
Nice.
So, and then what's interesting is that at 16.5 kilometers away, so the one just past 15 there, that also set off car alarms for the boom, not for the launch noise, but for the boom.
But for the boom.
Now, interestingly enough, the one just to the left of that, about 14.5 kilometers away, I was there.
Right.
This was at a boat launch, or boat ramp there.
Okay.
And there was probably 100 cars parked on the road, and not a single car alarm went off.
Really?
So there's something in the physics there. I mean, anecdotally, you're like at two stations, they're relatively close.
Yeah.
They measure a very similar overpressure. But one of them has, and so there's something else going on.
I wonder if there's something like the direction the cars were parked, because the road here is like this, you're parking the car's facing.
Or is it how fast the rise occurs?
There's water or terrain in between.
We're getting a whole bunch of questions from people, and I'm seeing them come through about like, how does wind direction or the particular weather that day, or how do these variables...
Let's move to the last graph.
Okay.
We're going to spend 2 minutes on that, and then we could take questions.
Okay, we'll do some questions.
All right, this is probably your longest.
By the way, this is
the longest video ever?
This is fantastic.
No, it's not by a long shot.
Okay, good. Okay, so I mean the overpressure. So the last thing on the overpressure, right? So by Brownsville, they definitely got a good thump.
Okay.
Right, but instead of a bang,
it was more of
it would be more of a thump. Right.
Like the neighbor 2 streets over is doing their subwoofer in their car.
Okay, sonic boom level then. These are 2 other metrics, right? And neither one of them is in the environmental assessment, but they're important because these are metrics that are being used right now by NASA for the X-59 program. Where they're trying to design, and that's a program actually I'm part of.
Makes sense.
We're doing measurements and measurement design for that, and some of the same hardware we're using there, we're using here.
Okay.
But we wanted to calculate those because it gives us a reference point.
Okay.
And the first one's known as perceived level, and
the PL is
perceived level, and this was a metric that actually does a pretty good job of mimicking the ear. For level and frequency and all that. And so just a couple of points there, right? So at 20 kilometers, you're around 110. dB. Again, different metric.
Which dB?
110, but PL.
Doesn't have an A after it. It's a PL dB.
So it's this perceived level. It's around 110 dB. So, I mean, what's the most famous aircraft sonic boom out there? It's Concorde.
Yeah.
Okay, so when Concorde's flying at 60,000 feet, about 18 kilometers up, it is, it's about, what was received on the ground, it's about 105 dB from a perceived level.
Okay,
So
so
what's that 5 dB mean then from perception?
from perception level. But the sonic boom from Starship was about 5 on that day, higher than
5
the
dB
Concorde would
than
have
the
done
Concorde would have been.
if it was flying over
Right.
your house in the
So
Midwest,
what does
whatever.
that mean? For that metric, again, it's pretty rigorously investigated. A 5 dB increase means about 50% louder. So 1.5 times louder. We would hear it as 1.5 times louder than the Concorde boom.
Okay.
Okay, so that's just, I mean, that gives you some sense, right? Because people didn't love the Concorde boom.
Right, that was the whole thing.
Right, and that was that ban of overland supersonic flight, right?
I think people just don't like cool stuff, but
I'm not here to
That's
talk
just
about
me.
the actual the impact. So just the science of what
This
we
is the
measured,
science
right?
of what was measured.
I will leave it to other people to determine what is or isn't acceptable.
Sure.
Right, but so that gives you some reference there.
Okay.
Now the other one I'll just point out with the sound exposure level, we did that one because we wanted to say, wait a minute, how much energy on the A-weighted scale is in the boom versus the launch? Because now it's the same metric,
right?
But for comparing two different events.
Okay.
And so when you look at that, right, it's about let's see, it's about 5 dB lower or so than the launch levels at these distances, somewhere like between 5 and 10 dB. And so it's a significant fraction of all that launch
The duration of the launch gets you.
It's huge. But even this one instant, you get a significant fraction
amount of energy
of the energy
received in your location, whatever.
Yeah, and I think that's all I want to say about that.
Okay.
Okay, when you put all these metrics together, we said we were going to do a vehicle comparison.
Oh, hey, there's a vehicle
There's your
comparison table.
Okay.
Nice.
I am not going through all the numbers here. Okay. I'll let you try to digest all of these. But when you take 10 and 20 kilometers for the SLS, and you take 10 and 20 kilometers for the Falcon 9, and we look at 4 different metrics for the launch noise, it looks like Starship at these distances for this particular day, and just kind of averaging, like very hand waving across the metrics, looks like about the acoustical equivalent of 4 to 6 SLS launches.
Holy cow!
I mean, that's what the numbers say.
That's amazing too, just because we famously, for the longest time, you think of those solid motors on a shuttle or an SLS, and it's like, those are the loud boys.
They're
like,
rough.
Of all rockets, those are the loud ones.
Yep. And then when you comes to the Falcon 9, it is approximately, I mean, I'm going to just, I'll use the language we used in the paper.
Okay.
It's at least 10 Falcon 9 launches.
Wow.
All at once.
And you can even guess that just based on the comparison of thrust.
Yeah.
Right, but the metrics back it up, and it could be more. It's probably not less than being the equivalent of 10 Falcon 9 launches.
That's amazing.
No kidding.
Acoustically. And that's just going across 2 different distances. Now, what does it look like closer? What does it look like on a different day?
Totally different
I can't answer
things.
those questions.
Right.
This is one data set. But we have one SLS launch, we have one Starship launch that we measured. Have a lot of the Falcon 9 though. We have a lot of Falcon 9
There's a lot of
launches.
Falcon 9s,
Those numbers are pretty darn good.
Those are pretty good numbers.
So anyway, a lot of work to be done there, but people want to know, how does it compare to these other vehicles? Now, that's not to say, I mean, I can whisper 10 times, I can whisper 100 times, there's still no impact.
It's not going to do anything, right?
So it depends on what the impact, if I say it's 10 times, right? I'm not saying it's 10 times the impact.
It's more of an interesting fact.
I'm saying the acoustical equivalent, and that's something that, again, people are going to have to sort out from that. But these data, why we pushed so fast to publish this paper, I mean, I literally stayed up 2 nights in a row writing this thing just so that we could get the data out so people can start having a rational scientific conversation on what is actually going on. It's not the end all be all, but these are data that are defensible.
Rational scientific conversation.
Who would have thought? Really?
Seriously though, it sounds like you're really getting the true Starship experience. You had to drive straight through for like 1,600 miles for 36 hours. You stayed up 2 nights in a row. Like, buddy, you're one of us.
I felt a kinship when I showed up, and I looked with all the lack of sleep. Anyway.
But that's how you get the data. Like, the important thing here is that you don't just make things up. You don't get, well, we launched a rocket in the 70s, and so I don't know, we think this one will be like this. You gather actual scientific data with a team that knows how to do it professionally. I'm not going to go out there and measure it, right? I'm not going to like put my little video mic. I just hit my mic, by the way.
I keep doing that. Sorry if you. Yeah, I keep doing that.
But it's not me out there with a little video mic and then trying to guess how loud the video. This is like actual calibrated scientific data that is now published. It's online. It's open, so everybody can look at it. So it's not just, oh, go and pay $100 to read this paper. Like that was a specific thing that y'all did so that the public could go out there and review the information. Right. There it is. Starship Super Heavy Acoustics. Far field noise measurements during launch of the first ever booster catch.
I love it.
Let's boost the journal just by make sure you download that PDF so that
seriously,
so the journal's metrics go up.
Okay.
Everybody right now go download that paper. Like literally, how many people?
Can their website handle this?
There are 2,073 people watching right now.
All right.
I want 2,073 downloads.
Downloads of the PDF.
Not just because it's a nice thing to do to help out, but also it's a really cool paper.
Because and the journal did push really hard.
They got it out
to help us all out by getting the data out as quickly as possible.
That is very cool. That you burned the midnight oil. You came out here. You drove all the way down here. And then you got the letter or you got the paper done. You got it to the journal, and they turned it around so that it could be released here. We thought that it was going to be really interesting. Another Starship flight coming up, and so now there's data that's relevant. You're out here to gather more, right?
Yep.
So we'll get some more data.
That's right.
From Flight 6, and then we'll have more data points.
More stations and closer.
More data, more better, in the words of Jack Beyer over here.
That's right. More data, more better. That is true.
Okay.
Thank you so much for really breaking everything down for us. Can I throw some questions?
Do we have a couple questions?
We have so many questions, but I want to respect
water
your time.
or anything? Like,
no, we're all right.
We'll
just keep going.
Just power through.
Okay.
I mean, I am a professor.
Yeah.
So when you said 30 minutes, I just immediately doubled it.
This is a lecture. Welcome to class. Everybody sit down.
You can't just answer questions. You have to start and break it down and every step of the way.
You did a fantastic job, like setting up the background. I wanted to jump like, straight to the results, but I wouldn't have understood the results as well without the background.
No, it's good to set the table before you have dinner, but you don't just want food to sit on the table.
No, man, I just want the dinner.
All right, what questions?
Okay, Hyena is asking, why is it a single discrete boom rather than like a rolling thunder sound that persists for the duration that the object is supersonic? Why do rockets not make a boom going up? Well, really quickly, Xylofoxlin put out a really good video on this in the last couple days about why they don't make a boom going up.
Right.
They actually do, but you're not in the...
It's not in that direction.
Yeah, you're not in the ellipse. But for the first part of the question, why is it a single discrete boom rather than a rolling thunder sound that persists for the duration that the object is supersonic?
Great question. So yes, it does make the boom going up. That's known as the ascent boom. So if you've ever been standing on the shore at a lake and a boat goes by.
Right.
Okay? So when the boat is traveling faster than the waves on the water, it creates a wake.
Right.
And it's a very discrete wake.
You can see it.
And it comes off at a specific angle. And there is a wave at the front. They call it the bow, right?
Yep.
I'm gonna even use the word shock, right? Bow shock.
Bow, yep,
and then at the stern, you can have what's called the tail shock. So when you're standing on the shore and the boat goes by, you get hit twice.
Yep.
The bow and then the stern.
Right.
And the sonic boom is basically the same way.
It's the same sort of thing.
Bow. And so it is generating this continuous boom as it travels, but as an observer, you only get hit
one time as the wave
pass by you.
If you could perceive the ongoing boom if you ran along the shore at the same rate.
You could hear it again and again and again if you could travel.
You could do that.
Right. About 500 miles an hour or so, you could be you could get the whole thing.
Okay, so it does, but at a fixed position, it only hits you one time, or number of vehicle elements that create a shock that hits you, like get the M boom or whatever.
The M wave, right.
The M wave.
Exactly.
But that's all from one event passing you.
Exactly.
Because you're not staying along that shock, right?
Yep.
We'll let y'all talk again some, Max and D, by the way.
Oh, I'm sorry.
No. Max and D, go away.
We'll get you back in a second.
No, that's a fact. Now, I just want to, when you say about this thunder thing, I do actually want to say something about it. I've measured ascent booms in Ventura County.
Really?
Yep.
Do you have to be like flying in a plane or something?
So, no. So the Falcon 9, when they do the Starlink launches, they fly close enough to the coast, you can get some
Really?
scent booms, and those sometimes actually are heard more as like a rumble.
Really?
And even though it's a discrete event, it does create more of a rumble thing because of how far away it is from the person.
Okay.
So what you hear can be perception, but it wouldn't be continuous. It's still an event.
It's still a wave passing.
It's a wave
shock
passing, but it can
passing.
have a rumbling-like quality to it.
Okay.
So I thought I'd mention that.
More questions. Speed run.
More questions. Okay, Wayland's is asking, this should be incredibly weather dependent, right? How are you controlling for the weather effect? Is it just, it's one data point, so you don't have a control yet?
Right. I mean, yeah, we can't control the weather or control for the weather. The point of getting is, you'd want as many measurements as possible so that you could build essentially a database and start going, oh, okay, this is how we think the weather is changing things.
Do you record the meteorological data on the date that you're gathering the instrument, or I guess somebody could cross-reference it with other weather databases if they wanted to make that?
It's for something like this. I mean, there are weather balloons launched.
Right.
There's weather stations. Yeah, we do collect weather data.
Okay.
But since we can't control for it, especially with this first paper, we're just putting it out there.
So it's an exercise for the researcher. Like, let's get 10 Starship launches recorded, and then you can start looking at the conditions that day versus the data that was recorded.
And that's an important part. I mean, part of the whole project I have going on at Vandenberg Space Force Base right now, which is an ecological acoustics project.
Right.
Did you have to put headphones on a seal?
Oh my gosh.
Oh my goodness.
You can't just ask that.
I'm sorry.
All right.
I'm sorry. I had to.
Moving that along.
Moving that along. So, but really, we are now to the point where, because there's enough of those launches out there under variable weather patterns, we're starting to look for those patterns.
Gotcha.
And now it's very difficult to model that, especially at a place like Vandenberg, because you've got the marine layer.
Marine layer.
Right? And so you can look at launch to launch. You're going, what on earth happened there? And it's not the vehicle, because if a station close to the rocket always records the same thing, but you're 5-10 kilometers away and you start seeing differences. And I know there are some interesting weather effects that are present in these data that we've already put out, but I mean that's another project altogether.
Gotcha.
So yeah, weather is a challenge, and it can change your answers by several decibels.
Yep. So you got to get more data points. You got to show up for more launches and record everything and build this huge data set that then humans and scientists and that sort of stuff can use to study and learn about things like this. Right.
Yeah. We may come back in our next paper and refute some of the trends.
Some finding for this.
That's how science works.
That's how science works.
We got to put the first data set out there.
Yep. You got to start somewhere.
Let's do this last one. It's probably related to the previous one. Oh, it just disappeared. I think the panel's broken.
Quick, make something up.
Can you ask about sound propagation and how sometimes you can hear rockets from miles and miles away, and sometimes you can't?
Yeah.
And the most important variables for that, is that there's a inversion layer that the sound is bouncing off of, or like a wind direction thing?
Great question. So there are see if I can keep track of all three things as I talk. Okay, the first thing, trajectory.
Right.
Obviously the heading of the rocket matters a ton.
Going away from you or past you or whatever.
Right, and so that matters. The second thing though is the pitch, right? How the rollover,
like the angle of attack, or how?
Yeah, like how quickly does it turn over?
Okay,
That depends on where they're trying to head with the vehicle.
Gotcha.
Right. Sorry, I'm blanking on the term.
It's
right
fine.
now.
Like the specific trajectory.
How fast does the rocket turn over?
Right. Okay.
Right. That kind of influences what you hear, and then that's the vehicle.
Right.
Right. Everything else is meteorological.
Gotcha.
Right? And so wind. If the wind is blowing from your back towards the rocket, it'll be quieter.
It'll be quieter.
Right? The sound is literally being blown away from you.
Yep, we get that at McGregor, like on some days.
If the wind's blowing towards you, it'll be louder.
It's louder. Like it's really calm one day and it sounds like this, and the exact same type of test with the exact same microphone on a different day, the wind's blowing like this, and you're like, you can barely hear it.
Yeah.
And then another morning you're like, I can hear the klaxon and the PA announcements. Like the atmospheric conditions, even we see it all the time at McGregor, drastically affect how you hear sounds.
Yeah. So anyway, I think that's one piece of it, the wind. But then you get to these, and there was the weather before we were showing kind of temperature profiles.
Yep.
So just like in the ocean, right? They have to talk about like thermoclines and stuff, right? Where beneath it, you can't even detect the submarine because the sound literally bounces
bouncing
off
of the temperature.
Right, they're not as extreme in the atmosphere, right?
Less density because it's
less
air
density.
versus water,
There's more turbulence. It leaks sound in more directions. But the sound tends to bend to where the sound speed is lower, which means typically colder.
Right.
Right, and so you can get channels in the atmosphere where it just propagates efficiently, and then all of a sudden it encounters a change, it's traveling along this channel, and then it just kind of bends back down.
Really?
Or it kind of reflects, it travels up, but then it reflects off of some sound, like some layer in the atmosphere, and just starts to bend, refract back towards the ground.
Yep. I got to ask about clouds. Like, it's a whole thing. I think that rocket launches sound a lot louder to me when there's clouds. Like the loudest launches, like vehicle for vehicle, Falcon 9 launches, seem really loud to me if they go up and then they disappear into the clouds. Is there something to that? Like the clouds,
that's a great question because as it goes through the water, you typically would think there's enhanced absorption.
Right.
And that would reduce your energy.
That's always confused me.
But I've had that experience at Vandenberg, and that's we're starting to collect enough data under different patterns that we want to look at it. I mean, but you can watch, like at Vandenberg. Sometimes you will have it get loud, quiet, loud, quiet, loud, quiet, like 4 times.
You hear
it, and it literally is doing that, and you're going, well, what's going on? What happened to the rocket? Right? No, the rocket's fine. It's just that it's traveling through these complicated layers, and that really can change our perception outdoors.
No kidding.
I've always wondered why. Also, particularly out of Vandenberg, there have been some launch. Like there was one Atlas launch. I don't even know how many years ago. Probably 10 years ago at this point. One particular Atlas launch that, like to this day, outside of the Starship launch, that is the loudest launch you've ever heard, or I guess SLS. Go figure, like whatever the conditions were for that particular launch.
That specific day.
But yeah, I mean, wow. Thank you, because I feel like we've all learned a whole lot here, and we're going to learn a whole lot more as you guys continue to gather more data. More data, more better. Got to say that it's in my contract. But yeah, it's just. Thank you. Thank you for taking the time, sharing your knowledge, sharing your excitement about this stuff, and so that people can now take the scientific data, gathered with real scientific measuring instruments, and come to some conclusions with it. And again, maybe you gather more data, maybe those conclusions change, but that's how science works. So
that's right.
Yep.
Thank you.
Yeah.
Real quick, let me say tomorrow, we're going to try to catch up with you again tomorrow.
Sure.
We'll be out in the field, and you have your measurement devices, the Pumas.
Yep. You're going to meet some of my students and a colleague that's down here, and we have our portable units for measuring acoustics.
Portable Puma, P-U-M-A.
Along with the compact outdoor unit for ground-based acoustical recordings, or the Cougar.
Wow.
I mean, I work with NASA.
You have to come up with stuff like that.
Everything starts with the acronym, right? Everything starts with the acronym.
But we're going to try, if we get the opportunity, we're going to try to catch up with you live in the field.
Absolutely.
And if we can't do it live, we'll record some of it so that we can see these scientific measurement instruments, how you deploy them, how you put it out. We'll catch up with some of the students. I wave over here because there's students over here, right? How that works. So this isn't the last we're going to be hanging out with Dr. Kent Gee and the students from BYU Physics.
Well, it's the acoustics group in the Department of Physics and Astronomy.
There we go.
Yeah.
Thank you so much for joining us this evening. This is fantastic.
It's been a fun conversation.
Excellent. Chat.
Thanks.
If y'all liked it, you know what to do. Make sure you click over through, check out the paper.
Download the paper.
Post it on social or whatever.
Download the paper.
Send it to your mom on. There's a lot of.
Please repost it.
Repost it. There's relevance in it. It's like, it's about as loud as a rock concert or this or that. So there's some things in there. Don't worry about the A weighting or Z weighting or whatever. Like you can explain that now, having watched this. Hopefully, if not, rewind it and watch it again. But anyways,
good deal.
I don't even know how long we just talked.
A lot.
A lot
is the answer. But
it's the flame trench.
Let's get Max and Dee back in here shortly. Thank you so much, Dr. Kent Gee, and Das also. Thank you.
Oh yeah. Hey.
Thanks for having me.
What do we do?
Well, in the meantime, while we get things situated here, I do want to thank all of our members, and I want to remind everyone what you get at each different membership level. So at PadRat, you get your name highlighted in the live stream and video chat comments during major event live streams from Starbase. Access to 4K 9-screen multi-view is provided. So the members multi-view is awesome. Red Team, all of the above, plus with additional access to YouTube member content. Capcom, you get all the above, plus NSF member Discord. And Launch Director, you get all your above, plus your name at the end of NSF Live episodes. And Flight Director is the same as well. I missed some perks in there, but there's the 4K multi-view. Yeah, it's an amazing program, and we cannot do what we do without y'all's support. But yeah, Red Team and above, exclusive photos, historical photos from L2, and video, such as behind the scenes and cool clips like that. So yeah, the Discord rules. If you're Capcom and above, the Discord honestly does rule. I think we'll be posting some food chat stuff in there, and of course there's also, like, you know, channels about rockets and whatnot. So enjoy the member Discord as we are in launch season, shall we say. Oh yeah, also Thrust Collection. I don't know if you can see my shirt, but yeah, Thrust Collection, it exists. Also, prints. Also, the patch has been released. So there is the patch. We have revealed it because, of course, there is a full stack now. So check it out. Check out the shop. Check out the membership program. Yeah, all this stuff exists. Also, oh, stickers, yay! So yeah, that's the plugs. You know, we do them because we like doing this stuff, and we like hosting science at our sites, and we like shooting cool photos and videos of rockets. So, you know, thank you for supporting what we do so that we can do this. All right, Max and Dee are back.
Hi. Hello.
I feel like my brain just got the best workout.
I genuinely have no idea how we're going to match that conversation. Like,
Yeah,
we may as well just cut the show here, honestly.
Well, you literally have to go to FedEx to grab your lenses, don't you?
I mean, they close at 7, so I have, like, yeah, a little.
Oh, wow, yeah.
All right, so we will get right into it. Let's talk about our photography and videography plans, and just what we're looking forward to. Maybe some of the shots from Flight 5 that we really enjoyed. And you know what we're going to try and sort of, you know, what we're thinking about trying to pull off for Flight 6 here. So I don't know, who wants to go first? You didn't even bring me a Topo Chico like I asked.
Oh, you did. Okay.
Okay. Right. So I guess since so this image on screen is all the way back from Flight 2, which, if Starship does end up launching on Monday, will end up being exactly 1 year to the day from Flight 2. And this was captured from Danger Lot on my Canon 80D with a 10-18 Canon lens on it. The way the plume comes back toward the cameras and the way it obstructs, oh my gosh, you actually brought him a Topo Chico.
Brought me a Topo Chico.
I forgot.
Thank
I was
you,
supposed to do that.
Thank you, Dee.
The way the plume essentially propagates outward from the orbital launch mount and between the legs, it obstructs the view more often than not for launch. So we have to be very strategic in how we want our frames to be set up. Do you want to go just for the pre-launch drama? Do you want to try and have the camera aimed up toward the sky, try to go shoot for the moon, see if there's a gap in the plume, see if you can catch it flying? Really depends. But obviously now with the variable now in play of the booster hopefully coming back to the launch site, we now can aim our cameras more toward the chopsticks or the top of the tower,
right,
or have the tower a much larger portion of the frame,
right,
because, assuming all goes well, the tower comes. Dude, I still look back on Flight 2 imagery and just like it's so good.
Flight 2 will forever hold a special place in my
Yeah,
heart.
me too. Me too. I mean, it was the first one to fly mostly like successfully, the first booster to fly with all 33 Raptors lit. For the first time.
Sanel in chat says, this pic deserves an Italian pasta hand kiss. Mwah!
It's like, the results from that day were just absolutely spectacular. Like every camera worked, the light was great, compositions just turned out even better than I expected. And of course, everyone else seemed to love it because there were a lot of prints sold, which I'm still very, very grateful for. This image as well, this was also Flight 2. Taken from the roof of the Margaritaville Hotel.
Seeing a trend here.
Yeah. And so essentially, what I was trying to go for here was try to catch a lot of the port exit from, I guess, would you call that Port Isabel or would you call that SPI, like the water there? I'm not entirely familiar with the geography of the area.
The water that we're looking at in the shot?
Yeah.
That's the shipping channel.
Okay. So the shipping channel that goes into the Port of Brownsville. And there's this RV park, and I think that's Isla Blanca Park, isn't it? Yep. Right there? Yep. I wanted to catch all the drama and all of the boats in the water, the people, the RVs, the trees, all of that in scale in the foreground to show just how much of a force of nature Starship really is when it flies in terms of the size of its plume. This time, being, of course, being the first time they used the water deluge system. So obviously the pad doesn't nuke itself. And just how big that plume is and how long, of course, as well, the exhaust plume is from all 33 Raptors.
How tall is a full stack again? Like 400 something foot?
About 400 feet, yeah. Yep.
So it's a more than a 400 foot flame?
I would honestly guesstimate it between like 500 and 600 feet long.
Yeah.
Oh, at least. Yeah. I feel like, especially once it gets higher in the atmosphere, that flame really expands.
It's the same with Falcon 9. Like if you're downrange, say for like a southeastern trajectory, and you're in like Satellite Beach, the rocket's like this, and the plume is like this long. It's ridiculous.
I wouldn't be surprised if at times the plume nears like a mile long once it's not fighting against all that.
That's amazing.
Oh, I didn't think about that.
Yeah.
Oh my God.
I'm excited.
Starship flights are just special.
They really are.
In case you haven't picked up on that already.
We're here for a reason. Like,
what is this guy?
This is actually Flight 5. This was captured on the Canon RF 600 with a 2x teleconverter on it. So about 1200 mil equivalent on the R5 full frame camera.
I love that plume expansion.
I know, and the thing is, this is cropped in so much, and by this point, it launched like just after sunrise. So the amount of ambient light on the ground wasn't really that substantial. So, of course, as it ascended, it was flying into the sunlight, and by this point, it was fully lit. The light was white. It wasn't orange. There was no color to it. So Starship was being fully lit, and of course, because you're in the upper atmosphere and the ambient pressure up there is so low, the exhaust from all the Raptor engines begins to expand, similar to what you see with Falcon 9 as it ascends. But because the exhaust or the fuel used is methane and not RP1, you get a whole bunch of different colors, like the plume interactions and just the colors, the shades, the shapes are all way different, and they're so beautiful. There's something so special about seeing a methane rocket fly. Like it is so pretty, and we saw that as well at the Cape from Terran 1 when that flew in 2023. So
I'm so sad I wasn't there for Terran 1.
Me too.
Like what an amazingly beautiful launch.
And we should have one more coming up, hopefully, if New Glenn flies the next.
You mean Glenny?
No, not Glenny. Not Glenny.
Not New Glenny?
New Glenny?
Newly Glenn?
New Glenny?
No.
New Glenny?
No. No.
Okay.
No.
But yeah, if once New Glenn does fly, oh, I love this one, Max.
Also captured. Honestly, me too. Like I was so pleased with the Flight 5 imagery as a whole, just because the Canon RF 600mm lens on the R5, even with the doubler, as you can see, it's ridiculously sharp.
Yeah, the
laws
of photography and doublers do not apply to Canon mirrorless glass and RF lenses.
Not
it's
at
absurd.
all. And of course, obviously, from this perspective, obviously, it's still higher up in the atmosphere, so part of the booster is still very well lit. Oh, Kevin. I couldn't even talk about it.
He's trying to help you. You have to go pick up your lens.
This was actually taken just last night as they were just completing the full stack of Ship 31 and Booster 13. So that light you see on the right-hand side of the screen is a drone that provides some kind of spotlight for other visuals and trying to get the ship lined up just right to sit on the booster. This happened like just after I think we heard it. Like you can actually hear the ship settle on the booster because the whole thing like
so there was a
groans. There was a thunk. Yes, because obviously as the weight of the ship is taken off the chopsticks as the ship makes contact with the top of the booster, the whole booster like creaks and groans under the weight and load of the ship from on top. So yeah, that was taken just last night. And the reason why the ship is lit so well, also in this one, there was a near full moon above our heads.
Yeah.
So the sky was nice and blue in long exposures. The ship, despite the dark-ish or very dark area around the entire launch site, was still lit very well because of that full moon in the sky.
Gotta love it.
So gotta love it. It's
cool.
It's good. It's pretty.
So going into Flight 5. You're gonna do a largely, same routine, or sorry, Flight 6. Thank you.
I was gonna say, sorry.
I was gonna wait for you to finish.
You spend months saying Flight 5, and it just burns into your brain.
When you keep saying end of November, Flight 5, and then it's end of November, and you're getting ready for Flight 6. It's easy to do.
It's only on the calendar behind you.
Hey, Flight 6. So yeah, like any things you want to change up for 6? Any things you're gonna do the same? Anything? I mean, and you don't have to like. Sometimes it's not fun to talk about because if a battery goes kaflooey, or something gets dewed over. Like, so if you don't want to divulge state secrets, no worries.
No, it's totally fine. But like, I think we have a lot more going for us this time as opposed to the previous launch windows from Starship, where the window was like 7 a.m. to 9 a.m. or 7 to 7:30, like very, very early in the morning, where the sun, if it's up high enough, the color in the sky is gone. It's super backlit from a lot of perspectives, unless you're north of the launch pad. So we have the luxury, and we're just fortunate enough to have a late afternoon launch window from 4 to 4:30 Central Time for Flight 6 that I'm going to change my viewing location from SPI, and I'm going over to our river lot to try and take advantage, hopefully, of good weather and good light of the entire stack in the launch pad from our perspective being lit from the front.
Yeah.
And so that, in contrast with hopefully a nice blue sky, maybe some clouds in there, should be hopefully really, really beautiful.
I'm on board for a very small amount of white fluffy clouds, because then you get some context as the rocket's flying past
Higher up
them.
in the atmosphere as well, because chances are if there's clouds higher up in the atmosphere, that means the potential of a shock or a vapor cone as the vehicle begins to go supersonic. We actually saw that as well from Flight 2. There was a brief and kind of faint vapor cone.
Yeah, I remember that. I remember the flaps got a little bit of fuzzy on there.
Yeah, exactly. And so basically, I'll be having the Canon 1200mm with me over at River. I think I'll have one, maybe two more cameras with me at River, depending on what I decide to do for remotes. But the game plan is pretty much just to catch the sharpest and the most intense and, I guess, intimate imagery possible. Because there was a lot that I wish I could have done different from Flight 5 compared to Flight 6, because...
No matter how many launches you've been to, and both of you go to so many launches at the cave, no matter how many you've been to, you always find ways to hate on yourself and want to do things better for the next one. But you both do fantastic work, so I get it. I get the feeling, but seriously, pat yourself on the back. No, do it right now. Pat yourself. Pat yourself. Do it.
There's work to be done, sir.
Okay. All right.
There's work to be done, sir.
All right. So D.
Yeah, so I don't do anywhere near as much photography. I mostly do video work. Like, most of my cameras are video cameras. So the photos that I...
That's a photo lens. Sorry, there must be something in my throat.
Yeah. Is that exactly?
Yeah.
Yeah.
So anyway, back to as I was saying.
Yes, please.
I do mostly video, so the photos that I have to show here are just from the last day since I got to Starbase. Just a couple little neat details. So this is actually a super close-up on the top of one of the chines on Booster 13, which something I think is really interesting about this is that the top of it says B12. Yeah. So
Tim Allen noises intensify.
There's so much speculation that could be done. Like, why is there a Booster 12 logo? Is it like they accidentally put it on the wrong one, or did they make a chine for Booster 12 and then decide that needed a bit, like something about it needed to change, so they saved that, but the label was already on it, and then they put the one for 13 on 12 and vice versa?
Maybe it's just a wrong label.
Maybe it's just a wrong label. Or I think that's plausible.
What if it's reused hardware?
Nah.
Probably not, but just imagine for a second.
That would be cool.
That would be cool.
That would be really
cool if it were reused hardware. Now, that is actually a very tight crop of an image. And also, so that was taken with this lens. And yeah, so that's the wider image to give you an idea.
You can just barely see the, show off the lens.
So this is a 400mm lens plus a 2x teleconverter. And then the body, which was a different body, it has a 1.6x crop. And then you saw that wider photo. So that was at the 1300mm equivalent, and then cropped into that section to be able to read that little logo.
Crazy how sharp that shot was, even with a doubler on there.
There were a lot of shots that were not as sharp, and then I got that one.
So if it was me and I was trying to take a clean shot of that label, I would stand there, I would shield my camera from the wind with my vehicle, I would set it on a 2-second delay from the shutter press, and I would literally not breathe, press. The camera takes a photo, hopefully after it's settled from me pressing the button, and then I would do that 30 times. When you see a label shot from somebody from Boca Chica, probably a similar process
Well,
to that.
well, Jack, the thing is, my tripod that I use this lens with was holding my video setup.
Ah, so you had to do handheld.
That was totally handheld.
That was handheld?
That was handheld.
Okay, that also deserves the Italian pasta chef kiss, whatever. Mwah! Like, good job.
Thanks.
What else you got?
I don't know. I think I have a couple more photos in here.
Banana for scale?
The banana for scale. I don't know. I just found that pretty cool. So that was one of the first things when I came out here was like I didn't stop at the bunkhouse or anything like that. I just drove straight out.
I wasn't
to the site.
feeling well. I was like, Max, D, please go shoot. I don't feel well.
So I drove straight out to the site, and then I walked out into the dunes and stuff, and then to the flats. And then this one was, I think this was actually a little bit later in the day once they had moved the ship into the chopsticks. Because the first time I went out, I went out with my video camera, and then I brought my stills camera out that time just to try to see. And I really like seeing the decals and stuff. But the thing that I find coolest about this shot is above the S31.
There's a camera.
There's a camera.
Yeah. I've been looking at those cameras since they've been, rolling Ship 31 around or any other ship that's got them. And I need to know what's going on with that glass. Like, is that a piece of quartz? Like, what's going? Like, is it just an optical piece of solid quartz or something?
To be, I mean, there's going to be a more normal lens in there. And then at a certain point, they have to have.
Well, because it's like completely. It's a box completely surrounded by heat shield tiles, but there has to be a clear thing for the camera and the lens to point through. I'm guessing quartz. I have no idea.
Like, it can't be just. I mean, that's going to go through all the forces of reheating, all that sort of stuff. Obviously not to the degree, but now we have seen glass crack on the cameras.
We have.
Yeah. So I would be really interested to know what it actually is.
Wait, sorry. Can we go back to the previous picture really quick, Kevin? Which really quickly. I'm sorry. I know I'm awful. I'm a terrible person. Really quick, please.
He's working on it.
There we go. All right, my favorite thing about this photo is the reflection in the flap. It looks like the banana is approaching some sort of like dimensional portal.
Like almost Inception.
Yeah, it's like approaching the boundary between two universes where it like meets its twin or whatever. Anyways,
yeah,
I'm insane. Moving on.
Yeah. So I like the decals. This was just a simple night shot as they were getting ready. We were all hanging out in the dunes, just sort of waiting for anything to happen.
We actually have some audio from when we were hanging out in the dunes, and we're gonna roll it here. No, I'm kidding.
I was gonna say, like, what?
I just wanted to see the look on both your faces.
All right. So good. All right, that's the end of this stream.
See y'all never again.
What else you got, D?
I think I have a couple. We can sort of speed up going through these photos. I think.
Love this one. I love this one.
This one I want to talk about. So this was out in the flats during the stacking, of course. And I had my video camera rolling, and so this one was a handheld shot up to the engine area. And in order to get the exposure, I basically had to sort of rapid fire and wait for the timing to line up with the flashing lights on the tower.
Yeah, because otherwise that engine bay isn't illuminated.
Yep.
It's at the exact right height for that light to illuminate it.
Yeah. So I took so many shots, and so that was on. I have a 50 to 100 millimeter f1.5 Sigma lens.
Fancy.
It has no image stabilization.
Ooh.
It's crop only.
Ooh.
But my
Still 1.5
stills camera, or did I say 1.5? I meant 1.8.
Still 1.8.
Yeah. So, and I think that was handheld at 1/30th of a second, fully zoomed in to the 100 millimeter mark.
Good job.
Thanks.
What I like most about this photo, and I'm self-centered jerk, so of course this is how I think, but what I like most about that photo is it's not a photo I would have shot, but I think it's beautiful. Like that, over there, the engine section thing on the wall, that's what I shoot like every time they do a lift. I'm like super zoomed in on the engine bay, like I want details, I want to see the engines, right? But that's not the composition. You can do a little bit with composition, but this shot is like, you threaded the needle. It was great.
And if we still had light out, I would have shot on the 400. I would have been trying to get that ultra close-up, clean engine shot, but
you can't really do that at night.
I can't extend the shutter speed long enough to, while hand holding, like it just won't work. So
Max, what were you about to say?
Well, like, and also, like, we all try to go to different spots for stacks, and you opted to go all the way out into the flats, like almost on the other side of the launch vehicle, which, again, I would never have thought to go over there, because why would you, especially at night with the lack of light?
Fun fact, that shot that's over your shoulder, that was also from out in the flats.
Was it really? Mm-hmm. I'm just a big dumb idiot, I guess, then.
No, you're not. It's a good spot for a stack, although sometimes they will have drones out there that literally yell at you.
Really?
Like, there were drones flying around.
But like, it's different from a camera drone or a light drone.
Well, they had the light drone, they had the camera drones, and they did have some that went out into the grassy area, and they actually did like hover near us very briefly, and then it flew off away.
Yeah, I've experienced that exact same thing, except the drone has a little speaker on it, and it goes, "You are in a danger area. You need to leave now." And I'm like, "All right, see ya." Like, okay, I don't know if you can hear me, but I'm out of here.
Do we think that was like earlier stackings and they've improved the process and now they're confident with it? Because we talked about how Starship as a whole is 400-ish feet high, and that location, like, SpaceX has all their property markers.
Right.
It's like 415 feet from the OLM, I think. So like,
it's like, if this thing fell over at me, how far away do I need to be?
Yeah, you'd want to get moving if it was tipping over.
Right. Cool. Well, I guess it's my turn now?
I think so. Yeah.
All right. Well, let's do this. First off, right off the bat, here is a shot that I'm simultaneously really disappointed in and really happy with. Camera was dewed over, so there was not as much light getting to the sensor as there should have been, so it's a very dark exposure, but hey, you know what that means? Nice mock diamonds. Also, the gradient of the lighting on the tower is endlessly pleasing.
I do have to say also the way you framed that and the way you cropped it is delicious.
Thank you, Max.
I love the way how it's almost a circle of the illuminated
right.
exhaust.
That's the dew. And in fact, like I was like, oh, it's so vignetted, but you know what? That's the dew. But yeah, that's that one.
And you can make out the ground fog layer there too.
Yes,
you can.
That's awesome.
What's disappointing to me about this one is I wanted this to be a properly exposed photo with the mock diamonds and also with, like, you know, a visible vehicle in there. But still, that 400-foot long blowtorch is pretty dang cool.
Blowtorch, I like that.
Yeah, right?
I like that.
Right? All right, let's move to the next one. Here, okay, Kevin, this one and the next one are meant to be like, just toggle back and forth between them and people will understand what I'm talking about. This was meant to be a composite. I am not good at Photoshop. I mean, I'm fine at Photoshop, but I'm not the best at Photoshop, right? So this camera was at Danger Lot. It fired a whole bunch of frames, and you can see 2 of the frames as an example there. So this is a composite shot. I have been so busy since launch, I haven't been able to put this composite together. So this is a shot that will exist at some point, but right now you're just seeing 2 unfinished frames out of it. But I plan on shooting something very similar for 6, just perhaps a little bit tighter. So there's that. And what do we have next for me? Okay. I don't think this was live on stream because I'm a big dumb face and didn't get the camera online early enough. But this is perhaps my favorite video that I've ever shot. You can see the shockwave go through the cloud. You can see it bounce off the ground and then go through the cloud again. This is a drone shot from our river lot. Yeah, so look for this shot hopefully live on Flight 6. We'll see how it goes. But yeah, the shockwave will just.
Can you see it hit the? Can you see it hit the drone?
The shockwave?
Yeah.
No, I don't believe so.
Okay, so normally you'd think that maybe like the drone might shudder or like move, like jerking it.
Right.
But like.
Well, you know, I'll have to go back and look at the raw footage. Truth be told, this memory card was corrupt, and I spent weeks trying to get the footage off of it, and I finally did. While I was hanging out with Anthony from Rocket Ranch, and like he literally got to sit there next to me while I had the whole entire like, oh please, and I finally got the clip off the memory card and then immediately re-encoded just this section, just so like whatever happens, I have this. So I'll have to go back and look. But yeah, I love this shot. Whole bunch of different ideas to do with a drone that is, you know, obviously completely legal. I'm a FAA licensed commercial drone pilot. I'm not flying in any of the TFRs or any of the areas I should not be. This is literally directly over our own property, outside the blast danger area, outside the TFR. So a lot of cool stuff that can be done drone-wise from the river lot. But yeah, that's that's the whole shebang. I will be shooting the launch once again on one of these puppies, which is a RF600 F4 that I just bonked myself in the head with.
I was about to say, it sounded like
heard something.
No, I
heard a little
I did bonk myself in the head. This is the same lens that Max is going to be using as well, so we'll both be using the RF600 F4. What?
No, mine's the actual 1200.
Oh, you rented the 12?
I rented the actual 12. So Canon actually makes an RF 600 mm lens.
I didn't know you rented the 12.
And so obviously, when you stick a 2x teleconverter on it, that becomes a 1200 millimeter equivalent lens. But Canon now also makes a literal RF 1200 millimeter lens. I don't know the specifics on that, but the way it's constructed, it looks like it's basically just a 600 f4 with the 2x like literally bolted onto the back
why
of it.
Would you even? Why would that even need to be a separate SKU? Like,
I'm sure they have
sharpness-wise over time as you're taking it off. It's another like
mechanical failure potentially or fatigue.
It makes sense if you're going to be shooting at 1200 versus 600 all the time.
Yep.
But
Santa in chat says Hubble just fell on Jim.
But like I use a teleconverter because I'll track launches at 400 2.8 and I'll throw a teleconverter on there, and I'm shooting with a camera that it has a 2x crop factor. So when I'm at the 400, I'm at 800 equivalent. If I throw the 2x teleconverter on there, then I'm at 1600 equivalent.
Nice. So yeah, I mean, if you're out there watching and you're like, what the heck does any of this mean? It means we are, as usual, working our tails off to bring you guys the very best content for Flight 6 that we absolutely can. Renting all kinds of gear, just using every piece of experience that we've gotten so far from 5 launches to hopefully bring you guys the best dang coverage of Flight 6 that anyone got. So yeah, that's I don't know, that's a good rundown, I think. Max, I'm not ready to end yet, but I'm ready to tell you, go get your lenses
go get your
from
lenses.
FedEx.
Do I just go?
If you
Just
want.
go. Do I just go? Okay.
If you want to hang out,
All right.
I'm not trying to kick you off.
I
but
love
also,
y'all. I love talking to you, but I legit have to go pick up this lens tonight. So.
All right.
You have 30 minutes. Yeah, it's a 20-minute drive.
You better go.
If you guys couldn't hear that, Das said you have 30 minutes, and Max said, yeah, it's a 20-minute drive. Das, if you want to take Max's mic, you're welcome to.
I can't right now.
Okay. No worries. All right, D.
Yeah.
Let's do some questions.
Yes, questions. Let's go.
James Hawks is asking, will FTS always be required? If Starship becomes as reliable and reusable as a 747, then why have to mess with an FTS?
So I would think so to an extent. There is the conversation about, okay, when it is a crewed Starship and the second stage is a crew vehicle, okay, then that changes the game a little bit. But we're still in the testing phases of all this. I don't think we can even begin to have that conversation of, do they even need FTS?
It's still a prototype, yeah.
Yeah, I think for now it is absolutely essential. We saw the tumbling that Flight 1 had and how long it took for the FTS to fire. So I assume that the conversation about FTS will be a long one.
Yeah, an ongoing and long one. Z16 Jim is asking, could they launch without doing a wet dress rehearsal? I think so.
Oh yeah, I definitely think they could. Based on what we thought was initially happening, they were Monday launch, which I think they're still officially targeting a Monday launch.
They still are officially targeting a Monday launch, even though there have been some rumblings and reports from various outlets about SpaceX looking at Tuesday due to weather on Monday. Nothing official yet, keeping our eyes open. Stay tuned to the socials for updates, et cetera, et cetera.
Yeah, so I mean, if they go for a Monday launch, there's not going to be a full wet dress rehearsal.
I don't think there could be.
No, timing-wise, what would they do? Close the road early and do it tomorrow?
Also, off the record and for planning purposes only, might be media activities at that same time.
Potentially.
All right, let's do some more questions. Why is Ship 33 using Raptor 2 over Raptor 3s? I think Raptor 3 is just not mature enough yet.
Yeah, they have a lot of testing to do. They're doing a lot of testing, but I'm sure they're figuring things out about the engine, doing minor adjustments, and getting their runtime in. They had a great flight of Flight 5 with the Raptor 2s. Like, it's not worth rushing the Raptor 3 to get the 3 onto the ship or onto the booster if that is the potential source of a failure. They might as well stick with what they know. They have so many Raptors, they might as well stick with what they know for now, and once they are ready, then they'll make the shift.
Yeah, makes sense to me. River Dave is asking, what's the camera count at this point? Well, we don't have Max anymore. I should have.
Okay. So personally, yeah, okay.
R5, R5 Mark II, 80D, 60D, 7D, 50D. That's 8. Plus GoPro, plus drone, plus, I mean, if you want to count a cell phone, like behind the scenes kind of thing, that's fully like 11.
So I have a Z-Cam, another of the same Z-Cam, another of the same Z-Cam that's not in use, a different full-frame Z-Cam. I have a red camera with me this flight. There's an 80D, an 80D, a T7, a T6, 7D.
I'm so glad you, Max, and I are all Canon people.
I have 3 GoPros, if we want to count those.
Yeah, count a GoPro.
3 GoPros.
Honestly, I don't throw shade on GoPro anymore. Like, as long as you set it up right, I don't think the footage coming off of them looks particularly GoPro-y, which used to be the kind of thing where it was like, yeah, if it was a GoPro video, you knew it was a GoPro video.
Yeah, so I have, I guess, 13 dedicated cameras with me. Plus, I mean, I also have 2 cell phones which will both be recording during launch.
The day phone and the night phone. That's a weird Mac reference that I don't think anybody would get, but I knew you would. So yeah, Max has a whole bunch of cameras. DOS is out here with cameras. You know, of course we've got all the SBL cameras. So many cameras.
I might be forgetting some stuff too. Like,
I could be as well. More questions. I almost said more cameras.
We always need more cameras.
Patrick is asking, what shutter speed would you choose to get sharp images during the fast descent? I would say no less than like 1250.
Yeah, 1/1250th. I'd say would be bare minimum.
1/1600 also good.
Yeah, basically, for me, I tend to set my aperture at liftoff. I have my ISO set at liftoff, and the shutter speed is the main thing I'll change throughout the flight because I don't want my camera to change on its own.
Right. If you change your aperture, that can change focus. If you change your ISO, that can change not only focus or not only exposure but color as well.
Yeah, and that is a concern. So I will change ISO only during nighttime launches when it's
like super expanded.
When it's really expanded, when we're getting a boost backburn, that sort of stuff. Okay, then I'm gonna up my ISO a bit. Otherwise, I'm sticking with a native ISO. And my shutter speed is what I'll change. There have been some launches I've gone up to 1/8000th of a second.
Yeah, sometimes you gotta, you gotta do what you gotta do.
On very rare occasions, I'll go down to 1/200th.
Yeah.
If it's later stages in flight and I really need the light. But for the most part, absolutely at least 1/1250, 1/1600, 1/2000th of a second.
Yeah. You know what? It stinks sometimes when you want a sharp image and you don't have a lot of light. And sometimes you just got to sacrifice the ISO, or sometimes you got to sacrifice the shutter speed. But that's the peril of the camera triangle is exposure, shutter speed, ISO. Like
that's what I love with shooting with the 400-2.8.
Because it's a 2.8?
It's a 2.8.
Yeah.
I can go down. I can see things that I can't quite see with my naked eye.
Right. For reference, for people who aren't photography nerds, for the aperture, that's the size of the hole that lets light into the camera body and hits the sensor or film. The smaller the aperture number is actually the larger the hole is. So a 2.8 is letting in way more light than, say, a 4. And I think it's like a doubling with every f-stop. It's like an inverse square. I don't even get me started.
And it has to do with a rate, because it's not just you look at how big the front element is, it's a combination of the focal length, it's a ratio of the focal length to the opening diameter that all works together. So that's why you can have a phone lens that is like f2, but obviously that's not letting in nearly as much light. It's only covering a small area. And there are a whole bunch of trade-offs we don't need to really get into.
I think that is a sufficient amount of nerdery camera-wise. Y'all, I hope you enjoyed this one. What, like, best flame trench ever? Dare I say it?
I would absolutely.
Am I allowed to say that on air?
So far.
That was a treat. Let's do some support and wrap things up, because we are about to premiere a new video on this very channel here in about 5 minutes. So
we really don't have long.
So I really got to speak on the support. Alex, thank you for the support, getting a Mary print and some stickers. They say superb update to the intro video. Good work, Ryan, by the way. Thanks for adding sticker patches for those of us who didn't collect initially, and paper prints are much appreciated when I prefer not to mount magnetic hardware to my wall. Thanks for rolling those out. Go Flight 6! Thanks, Alex. Steve Kalovic, thank you for the 20 super. They say, what is something about photography that each of you learned from someone else on the team? Ooh. Do you have any?
The amount of advice that you gave me during the drive to New Mexico.
Really?
Specifically, specifically related to shooting Virgin Galactic.
Yeah.
Like prepping the tripod legs uneven, that sort of stuff. Like it sounds silly, but there are so many things, and I know that there's so much more. Max has absolutely helped me with editing photos before.
Max is a legend. He's helped me editing photos a whole bunch.
Absolutely. And so there are a whole bunch of details you don't think about until it's something you've done before. And you've been at so many of the space plane flights. And with rockets, you're used to the trajectory being like sort of up, but you're never looking straight up.
Right.
With that, you're looking
straight up
along the side, and then it comes towards you, and you're looking straight up,
literally 90 degrees
backwards.
Yeah.
And that's something you have to be ready for. You have to have the tripod ready for, or you will not be able to track it.
I forgot about that. That whole entire amazing journey is just like a blur in my mind.
Yeah,
good
definitely.
times. At some point, we're gonna have to take the however many 1,000-hour driving stream that you and I did and chop it up and put some highlights out. At some point, I know in all your copious free time, but at some point that'll have to happen.
I think we had 26 hours.
Madness. Also, the bacon stream needs to exist in some form or another at some point down the line.
That'll be like a super cut of the Fantastic Adventure.
All right, I gotta keep going here.
Yep.
Tim.
Yes.
Kevin
was with us the whole time. I turned down my audio.
So. Kevin, we were bros already, but I feel like that moment in particular was like we really solidified our broage.
I learned so much about you guys, both of you. Like,
that's
and
terrifying.
like just how cool you guys are. Like,
well, thank you.
No, I'm gonna put my wall back up. I gotta build the wall. Another brick in the wall. Chris, thank you for the support. Don't worry about me. I'm fine. They say thanks for patch 6. Keep up the good work. Ethan, thank you for the support with the store purchase. Ellie, Mary, thank you for the super chat. James, thank you for the store purchase. Austin, thank you for the tip to tips.nasaspaceflight.com. Neil, thank you for the support. They're flying all the way from UK for Flight 6.
Nice.
Good job. Steve, thank you. Plutonium-239. They want holographic bacon decals in the store.
Wait. We have to make this happen. Adrian, you have to be listening.
I don't want to make Adrian mad. Jacob, thank you for the support. Ninja Decimator. Pew, pew, pew. Thank you for the support. They say, will the weather be good enough for Yak to be in a kilt on launch day? No. GeoHound65, thank you for the support. I'm not even going to read that.
Oh, no.
Wait, maybe I will. For Jack, great Flight 6 patchy with Hoppy watching Boosty Catchy. Oh, I feel dirty. Telstar86, thank you. Benjamin, thank you. Parker, thank you. Dave, thank you. Space Pope with a $50 super chat. They say, bless this trench. Thank you, Space Pope. May your reptilian glory spread throughout the universe. Devin Waldron, thanks for the support, gifting 20 Red Team memberships. Daniel, Russell, becoming a Capcom member. Aramel, John, Harker with a store purchase. LM Mayo, I'm rapidly running out of time here. Telstar86 or Aurora, with a store purchase. They say, thank you everyone at NSF. Yeah, Telstar wanted us to ask about the VAB squeal on, VAB squeal.
The
Ooh.
VAB.
Oh,
the
God.
VAB squeal.
Oh, God. Just end it. Just end it.
Wait, are we calling it VABby now?
Jeez. I can't. Aurora says, thanks to everyone at NSF. You make watching the live streams entertaining and fun, plus very informative. I'm looking forward to seeing the launches.
I think the timer has run out.
And Mars.
Oh, wait, is there a new timer? Do we have more time?
I would love to go make history. Wait, what? What's going on? Oh, this is the premiere.
It's in the countdown now, so we have a little bit more time.
Okay, this is the premiere. Okay, wait. Okay, okay. Now I really have. Okay, Aurora, thank you. Anonymous, thank you for the store purchase.
We have 4 minutes.
Fixation, thank you as well. Mike Bundy, they say primes for the win. These are prime lenses. And bracketing. Shh.
This one isn't prime lens.
That's not a prime lens. Don't.
Max gets to go on the floor now.
Max is going to get his prime lens right now.
Yeah.
John, thank you for the store purchases. They say thanks for all you do. The NSF team is bringing amazing footage with each and every launch. We appreciate your efforts. Can't wait for Flight 6. Excitement guaranteed. Indeed. And Jacob, thank you for upgrading to Red Team. I know it's a lot to read out, and I know y'all probably want to hear us nerd about sound or camera things or talk about Starship and SOS and all that, but again, we can't do this stuff without you guys. We can't do this stuff without your support, especially our launch directors and especially our flight engineers, the 2 higher levels of support. You can see all your names there. Thank you so very much, because we all have the coolest dang job. And yeah, I think we all really love what we do. So the fact that you enable that, and not only that, you enable everybody around the world who might not be able to contribute monetarily to get breaking spaceflight news from us. It's really amazing. It's pretty dang cool.
Yeah, getting to be out here, talk about this, hang out with these great people. I've got to be honest, like, I thought the audio segment of this was going to be a bit shorter, and I'm so thrilled with how long it went. Everyone on the stream couldn't see this.
Oh yeah, you were running around swapping batteries and changing. Yeah, that was fun, huh?
I mean, yeah, I was like worried if the receivers were gonna start to die, but Max and I were standing here for so much of it, just like staring over it. I'm sure they felt like people were staring over their shoulders.
Every time Dr. Gee said something cool, I would glance over at you two, and you were both like, oh!
We would like look at each other and be like, what?
I was doing the same thing. 10 Falcon 9s? What? That was such a cool interview.
That was so cool. I want to talk with him. I want to hang out with him. Just hear him.
I feel like we already learned so much, and there's so much more that we can learn.
Yeah, but his depth of knowledge is incredible. So.
Real treat. Well, I think with that, we have a Matthew store purchase. Thank you, Matthew. They say can't wait for booster and ship catch in one day. That's gonna be sweet.
Yeah.
All right, Kevin Michael Reed operating the stream. Thank you, Kevin Michael Reed. D, thank you for being on.
So glad to be here.
Das, also thank you for being on. Shout from across the room.
Microphone's on right here.
Thumbs up. Alrighty. Max was on earlier. Thank you to Max for being on as well. And of course, thank you to Dr. Kent Gee from BYU Acoustics. What a treat. What an absolute treat. Cool. Well, I'm Jack Beyer for NSF. We're gonna go not be on stream for a little bit and maybe prep some cameras and things for.
Maybe tear down this setup.
Maybe tear down. Well, I don't know. I like this setup.
I do. I do need to do that still.
Oh my god, I'm so hungry.
And here we go.
We have liftoff. Propulsion continues to be normal.
R68 chamber pressure looks good.
Following up. Roger, roll, Atlantic.
Water towers, fly! Yes! Echo down to nominal.
Flight downside FD off. Bring in FD off. It's orange! 125!
Oh my god! Oh my god!
Décollage! Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.